Welcome to this GCSE Maths 2026 Paper 2 Higher warm-up video. This paper is designed specifically to warm you up for the Edexcel paper and looks at the topics that haven't yet appeared on the Edexcel Paper 1 exam. As you go through it, please have your calculator ready, be ready to go through some of the questions, and there's quite a lot of topics in this. The video is over 2.5 hours long, so I do recommend that you kind of skip forward through the questions and find the topics you want to revise, but also you could watch it at 1.5 or twice the speed so you can get through it a little bit quicker. I hope you find it useful, and there's some nice tips in here, tricks about how to use your calculator, and at the very end I've got some kind of key tips to help you maximize your marks in your exam. Hope you find it useful. Before we start, just a quick note on calculators. These are the three main calculators that you would likely to be using for your exam, with the oldest model being on the left and the newest model being on the right. Now the two calculators on the left are very similar in terms of layout and in terms of functions. The one on the right is the newer model, which is slightly different. So throughout this video, where it's appropriate, I will talk about how to do specific skills on your calculator, but particularly focusing on the middle one and the one on the right. And then if you use the one on the left, it should be equivalent to the one in the center. As with my paper 1 video, there's no guarantee that these topics will definitely come up in paper 2. They could come up in paper 3 as well, or they might not come up at all. However, because we've seen paper 1 already, this will give you some sort of a guidance of, okay, these topics have already appeared, so they probably won't appear again. So this helped me to tailor the content of this video. So the first topic you could be asked is just to use the calculator. And what they expect you to do is just to see that you can use each of the operations effectively. So what we have to do, and this is the advantage of using these calculators that I mentioned earlier, if you use the one, you can set up your display to look exactly like what's written in the question. And if you put all of that into your calculator, and I encourage you to try this now, press equals, you should get an answer of 5,058.47931. They've asked you to write on all the digits on your calculator display. That's all of our digits. And then the follow-up question might be rounded to one decimal place, two significant figures, etc. But in this case, all we have to do is write all the digits from our calculator display. The next question seems relatively straightforward. However, this is where a lot of students will make a mistake in terms of putting mixed numbers into their calculator. Often we'll use our fraction buttons, but that's not completely correct. What we want to do is we want to press the mixed number button, which is actually above the fraction button on each calculator. So you can see it here, and you can see it here. To access that feature, you'll press Shift and then fraction, or Shift and then fraction, and that will give you your answer. So have a go, and if you stick that into your calculator, it should give you an answer of 329 over 148. Now our question asks us to write that as a mixed number. Now on the newer calculator, you can just press your format button and that will give you a mixed fraction. On these older models, it sometimes confuses people, but actually above the normal button that we would use to convert between fractions and decimals, you can write to mixed fractions. So again, if you press Shift and then SD, that will give you your answer, which in this case is 2 and 33 over 148. Now you will notice that some topics will overlap between my paper 1 video and my paper 2 video, but that's because there will be crossover in topics, and rounding is one of those that's really important that we just make sure we have fresh in our mind so that we can make sure that we get this mark at the end of a question. So again, rounding to one decimal place, we look at the first number after the decimal point, which is a 4. That 9 means we're going to round up, so we get 2,758.5. The next one asks for two decimal places, so we need to look at two decimal places, two numbers after the decimal point. Now this 7 is going to round the 9 up, but then that 9 becomes 10, which means we carry 1. So it's that example again of double rounding. And in this case, it's 2758.50. Again, two decimal places must be present, so even if it's a 0, we have to put the second decimal place. Significant figures are slightly different, and significant figures are based on the very first digit you find that's not a 0. So in this case, it's the 2. So the 2 is the first significant figure. Now, in this context, one significant figure in this number, well, that just means we're rounding to the nearest 1,000, because that 2 is in the thousands column. So therefore, to the nearest 1,000, that's 3,000. Question D says two significant figures. So again, we go 1, 2. So our first digit, our second digit, and again, they have to be consecutive. Even if this 7 was a 0, that would be our second significant figure. And again, we're now looking, our 7 is in the second position, and that's in the hundreds. So we're actually rounding to the nearest hundred, which in this case is 2,800, because the 5 will round the 7 up. Finally, we've got truncating, and truncating isn't asked very often, but it is worth being aware of. To truncate just means to cut. So we just go and we just cut that number. It doesn't matter whether it's a 9, whether it's a 2, whether it's a 5. We're just going to cut off that number and just go from there. So we get 2,758.4. We don't worry about rounding, we just cut it off, and that's what they mean by truncating. Now, similarly to what I said in the first video, highest common factor, lowest common multiple. There are some functions on the newer calculators that allow you to do this, and if you're aware of those, please use them. But this method will work no matter what calculator you have. What we're going to do is, again, the same thing we would do if we do non-calculator. We're going to write it as a fraction. Where our calculator helps is we don't need to simplify this manually. We can just put 45 over 330 into our calculator, and that simplifies for us to 3 over 22. Then to find our highest common factor, we just divide the two numerators, which is 45 divided by 3, and that's 15. And the lowest common multiple is 45 times 22. And again, we're not worried about doing that calculation because we have a calculator. 45 times 22 gives us 990. So our highest common factor in this case was 15, and our lowest common multiple was 990. And again, we just write it as a fraction, putting our smaller factor on top, simplify it down, and then divide the numerators to get your highest common factor, and cross multiply to find your lowest common multiple. Now, prime factorization is a skill that a lot of students would have to be really ready for paper 1 with this, but it can appear in paper 2 and 3, and it has done in recent years. And actually our calculators have built-in features for this. In both cases, you have to take that number and put it into your calculator, and then press equals so it's in that answer position. So here, for example, on this calculator, it's got the -2. You want the 3725 to be written there. Now, on the older model first, what you're going to do is you're going to press Shift, and you're going to look here, and it says fact here. That fact means prime factors. So you're going to press Shift, and then you're going to press this button that's got a degree and a couple of apostrophes on there. So if you put that number in there, press Shift, fact, that will give you an answer on your calculator display of 5 squared times 149, which is in prime factor form. So it's written as this product of prime factors. On the newer calculator, it's slightly easier. Again, you put your 3725 in, press EXE or equals, so press your EXE to put in your answer line. And then if you press Format, under Format there is prime factorization or prime factor, and then that will give you the answer that you need. Now, this is a harder prime factorization question that they could ask, and it's just an adaptation of it. So it gives you A in its prime factor form, and then gives you 484A as a product of prime factors. Now you could go, if you do this without a calculator, you'd write 484 as a product of prime factors, and then you would use your laws of indices to combine each of those. In our case, however, all we have to do is in our calculator write 484 times 3 to the 4 times 5 times 7 squared times 11. And if we put that into our calculator, 484 times 3 to the power of 4 times 5 times 7 squared times 11. And that gives us the following answer. It gives us 105,654,780. So that's 105,654,780. Now once it's the product of prime factors, again, just use the trick we did before. Shift fact or your format, prime factors, and that will give you your answer, which in this case should be 2 squared times 3 to the 4 times 5 times 7 squared times 11 cubed. So you can see all that's been added here is this 2 squared and then 2 of the 11s. Now, fractions again is another important component in each of these. So we're asked to find a fraction amount. So for example, 13 over 72 of 65,093. Now, normally we'd say, well, we divide by the bottom times by the top. You can do that, but on a calculator, this word of just means multiply. So on our calculator, we can just write 13 over 72 multiplied by 65,093. So 13 over 72 times 65,093, and that gives us an answer of 11,752.90278. And then it wants our answer to 2 decimal places. So again, even though it's a 0, 90, and that's us finished. The next one, again, similar questions did appear on paper 1, but it's worth just being aware if something similar is to come up again. The issue here is the units are different, so we need to make these into the same unit. So this becomes 1,800, and now we just do the first number over the second number, and again we let our calculator do all the work. We just put that into our calculator, and that gives us an answer of 59 over 300. Next one, we have Dev has a bag of flour that he has used 2/7 of. There's 450 grams left in the bag. How much flour did he originally have in the bag? So we know that 2/7 of the flour is equal to 450 grams. So we know that if we had done, thinking like we did the first one, 2/7 times something gives us 450. Well, if we want to find the flour, the total flour, we could just do 450 divided by 2/7. And again, we don't have to worry about that because our calculator will do all the work for us. Divided by 2 over 7, and that gives us 1,575 grams. That was our original amount of flour. And then finally, write 47 over 1211 as a truncated decimal. So we stick that in our calculator, 0.22274 blah blah blah. Now you'll notice that when you do this in your calculator, there's a little dot there on top. That means recurring. However, if you scroll to the right of your calculator, you'll notice that quite a bit along there's a second dot. Now this doesn't mean that all the 2's are recurring. It means that between that 2 and whatever that last digit is, which in this example is a 3 all the way along to the end, then it means that whole pattern repeats. So again, it's not just 22222, it's a 2 and then all these other numbers. So you can just ignore this recurring symbol. Then when we truncate to 3 decimal places, well, naturally that 7 normally rounds up. Remember, when we truncate, we just cut and we don't round. So our answer is 0.222. Now, recurring decimals can also come up on paper 2 or paper 3. And what they often write is they say, prove algebraically that this can be written as a fraction. Because if you were asked just to write as a fraction, you could just put in your calculator, press the equals, your calculator will give you the answer. That's why they ask you to do algebraically. So just a reminder, we go x equals 0.509 and the 0 and 9 are recurring because that's our original decimal. Then we get rid of the non-decimal place, so there's one non-recurring digit, so that's 10x is equal to 5.09 recurring, and that's equation 1. And equation 2 then, if you look, you've got 1, 2, 3 places, so that's 1, 2, 3 zeros, that's 1000x is equal to 509.09 recurring, and that's my equation 2. Now I'm doing equation 2 minus equation 1, so that's 990x is equal to 504, because 509, again, the decimals, recurring decimals cancel, you get 509 divided by 5 is 504. X equals 504 divided by 990. Now, just because they've asked you to prove it algebraically doesn't mean you need to show every step. This simplification you can just put in your calculator and it should give you 28 over 55. If you do this and you don't get the answer they say you should, you've probably done something wrong. So it's a good indicator to go back and check your work. I'm going to leave the other question for you to try in your own time because again, you have the answer there to check what it is, but that one's worth trying too. Now, percentages, so find 187% of 3,500. When we're working with percentages, I recommend when using a calculator, use multipliers. So to find 187%, we're going to write that as a decimal. And we write as a decimal by just dividing by 100. So that's 1.87. So we just do 3,500 multiplied by 1.87. And then we let our calculator figure that out for us. And that gives us 6,545. Now the second question asks us to decrease by 21%. Well, we always start with 100%, and we're taking away 21%. That gives us 79%. And now we can write this as our decimal in the same way we just did before by dividing by 100. That's 0.79. So our multiplier is 0.79. And then we just do 3,700 times 0.79. Put that into your calculator and you get your answer of £2,923. And we don't need to add or subtract at the end. We've done all that when we worked out our multiplier, so that's our final answer. Same we do the next one, write one number as a quantity of another. Now in a non-calculator method, I recommended that you write this and then make the denominator into 100. On a calculator paper, it's much easier. You do the first number over the second number, and you just times by 100. And if you're trying to convert a decimal to a percentage or a fraction to a percentage, you just multiply by 100, and your calculator will do all the work for you. And that gives you as a decimal, as a percentage, 151.81 recurring, so we'll just say 8% to one decimal place. Finally, we've got 32% of a number is 75, and we want to find 170%. Well, again here we can just use that multiplier trick, or that scale factor trick that I showed you in the last video, which is 170 over 32. And the advantage here is, again, our calculator will do all this for us. So we do 75 times 170 over 32, which gives us an answer of, in decimal form, 398.4. So it goes 4375, we'll just go 0.4. So 398.4. Now, we can be asked percentages in a lot of different contexts. This first one, we're asked to find the original price. So that was that hint that we're going to do reverse percentages. So we're going to start with our multiplier, 15% off. That means we're left with 85%, which is 0.85 as your multiplier. Now, because we're going backwards, the only time we do this with a multiplier, when we're doing reverse percentages, we're going to divide by our multiplier instead. The reason that is because what we've done is we've done 0.85 times something, the price of the laptop, and that gave us £450. So therefore, to get the original price on its own, we do 450 divided by 0.85. So 450 divided by 0.85, and that gives us an answer of 529.4117, etc. Now, it doesn't tell us what to round to, but because we're working with money, we need to round to to 2 decimal places or to 0 decimal places. So they might say give your answer to the nearest pound, or they might say to the nearest pence. So in this case, £529 and 41p was the original price. Next one, compound interest. There is a formula for this, but I prefer not to use it. It's just, I think it makes it a little harder than it is. But if you know the formula and you use it, that's great. It's on the formula sheet, so you can just apply that. But again, interest means an increase. It's going up. So we're going to start with our 100%. We're going to add 3.2%. That's 103.2%. As a multiplier, that's 1.032. So we're doing 6,200 times 1.032. And we're doing that 5 times, so times 1.032 times 1.032, etc. And that just takes too long. We can use our laws of indices to make this a little bit quicker for ourselves. And we write our multiplier once, and then we just do that to the power of 5, because we want to do that 5 times. And then when we work out the answer, we end up with, again, we're working with money, so 2 decimal places, £7,257 and 55p. Next one, population of a town decreased from 120,000 to 95,000. Work out the percentage decrease. Remember, percentage change is change over original times 100. So the change here is 25,000. That's how much we've decreased by, over the original, which is 120,000. And then to make it into a percentage, times it by 100. And when we work that out, we end up with 20.83. So 20.8% to one decimal place. So it's a 20.8% decrease. Finally, it says the value of a car depreciates. So depreciation is just a decrease. So it means it goes down in value by 18%. So an 18% decrease, we'll use what we've done before, that's 0.82. And then 7% every year after that. So that's a multiplier of 0.93. So if I buy a car for £28,000 and I can stack these multipliers together, I'm going to do my 0.82 for 1 year because it was the first year only. And then I'm doing 7% every year after that, so 0.93. And I want to find the value after 4 years. Well, I've used one of the years, so I've got 3 more years to use, and that's after 4 years. And again, just using your calculator, and that gives you an answer of 17,175.27. And the next question is best buys. Now with best buys, the problem with each of these is what you want is you want to have the same quantity for each one. So we've got different quantities here. You can scale it up or you can scale it down. I always find it easier just to find the price of 1 gram. So first thing we're going to do is we're going to convert this last box into grams. That's 1,200 grams. And then so we don't end up with any weird decimals, I like to convert all of these to pence. So 225p, 350p, and 550p. And now we're going to go, well, if 500 grams cost this, well, 1 gram then is 225p divided by 500. 225 divided by 500 gives me an answer of 0.45p. Now that's not 45p, that's 0.45, so it's less than 1p per gram. The next one, we've got 350p divided by 750 grams. And that gives us an answer of 0.46 recurring, so 0.467p. Okay, so again, we're going to just put 3 decimal places there because we don't know what the last one's going to give us. The final one then, 550 divided by 1200, so 550 divided by 1200, and that gives us 0.458, 0.458p. And this just stopped at 45, so that's technically 450. So now we've got the same number of decimal places. So because we found the price of 1 gram, the best value is the cheapest one. So the 500 gram box is the best value. Currency conversions is another topic that's usually on a calculator paper simply because they can then use the proper decimals and it takes away the difficulty of doing the calculations. So we've got someone who's got $420 and he's going to convert them into euros. And we have the exchange rate from pounds to dollars and pounds to euros. So the easiest way with an exchange rate, because we're in the UK, it's always going to be £1 is equal to whatever the other currency is. So if you're converting from pounds, you're going to multiply. If you're trying to get back to pounds, you're going to divide. So therefore, to convert those pounds, or those dollars I should say, into pounds, we do 420 divided by 1.34. So 420 divided by 1.34, and that gives us 313.43. Now, rather than then retyping that into our calculator, because the answer is already in there, on our calculator we can just do answer times whatever we had. But the calculation we're doing is 313.43 multiplied by my euros now, 1.15. On my calculator I can just go answer times 1.15, and that gives me an answer of 360.447, which means that it's 360 euro and 45 cent. So our final answer in euros is 360.45. And again, all money will be to 2 decimal places. Ratios, if you haven't watched my first video, I do encourage you to go back. I've done very similar questions to this, but you can do this in exactly the same way. So we've got Bill and we've got Ben, and they're in a ratio of 5 to 7. And every time we want to find the scale factor. And the scale factor is always the amount of money, 720, divided by something. In this case, the 720 is the total. So we're dividing by the total number of parts, which is 12. Okay, because 7 plus 5 is 12. And then 720 divided by 12 gives us a scale factor of 60. So that then means we're just multiplying each side here by 60, which gives us 300 and 420. So therefore each of them Bill gets £300, Ben gets 420. The same sense in the second question, we've got the same ratio, Bill and Ben are in 5 to 7. In this case though, 720 is Bill's share. So our scale factor is 720 divided by whatever Bill got, which was 5 parts. So we do 720 divided by 5, and that gives us 144. So in this case, our scale factor is to multiply by 144 each side. Now we already know that gives Bill 720, and then Ben gets 144 times 7, which is 1008. 1008. So how much does Ben get? Well, Ben gets £1,008. Final question, you see this word more is bolded, and it often is bolded, but they could write the word more or the word less. But that just means when you see that, you're going to find the difference between the ratio. So again, we've got the same ratio. We're going to find our scale factor, which is 720 divided by, in this case, it's the difference between them because of this word more. So the difference is 2, so that means my scale factor is 360. So then I'm multiplying each of these by 360. So 360 times 5 is 1,800. And 7 times 360 is 2,520. 2520. Then it says how much do they work out in total? Again, always go back and read the question again when you think you're finished. So it asks us to work out how much we have in total, which is 2,520 plus 1,800, which gives us an answer of 4,320. Now, combining ratios is another skill. So you're given A to B, you're given A to C, and there should be some level of commonality between those ratios. At least one of the letters should match. So we're going to write this as a single ratio, A to B to C. Now what I do is I stack these underneath each other. So A to B is 7 to 4, and A to C is 3 to 8. And I've got some gaps there, but that's fine. I'm going to combine these together by looking at my A column, and I'm going to find the lowest common multiple of 3 and 7, which in this case happens to be 21. Now to get from 7 to 21, I've multiplied the first line by 3, and to get from 3 to 21, I've multiplied the second line by 7. So I'm going to do that with the other values. So 3 times 4 gives me 12 for B, and 8 times 7 for C. 8 times 7 is 56. Now the question asks, what is B to C as a ratio in its simplest form? So B to C as a ratio is 12 to 56. Now you have to simplify this. Now you can do something really quickly on in your calculator, is you can just write this as a fraction. 12 over 56 is equal to, and on your calculator that will give you an answer of 3 to 14. That's equivalent to what we just had. So therefore B to C is 3 to 14. So you can write ratios as fractions in your calculator, so small over big is what I recommend. And then when it simplifies down, you just fill the values in, so the small number goes under the smaller number, the bigger number under the bigger number, and that's your simplified ratio. And that allows you to simplify ratios using your calculator. Algebraic ratios, on the other hand, can sometimes cause some difficulties. But what we can do is, again, use that fraction trick. So x to y, I'm going to put x on top and y on the bottom. And that's equal to 8 was x, so 8 on top and 5 on the bottom. Now what we're going to do is we're going to cross multiply here. So we're going to do x times 5 is 5x. And we're going to do 8 times y, which is 8y. And then it's saying write an equation for y in terms of x. That means we should have y equals something x. So we're trying to get y on its own. So we're going to divide both sides by 8. Those 8's cancel, I end up with y equals 5x over 8. Or if you wanted, you could have y equals 5 over 8 x. Either one is acceptable. We can apply the same logic to the second question. X plus 2 over x minus 3 is equal to 17 over 10. And now we're going to cross multiply. 10x plus 20 is equal to 17x minus 51. And now we can rearrange and solve. I'm going to bring my 10 to the, I'm going to bring all my x's to the right hand side. That gives me 17x, take away 10x is 7x, and 20 plus 51, because the opposite of minus 51 is plus 51, gives me 71. To get x on its own, we divide both sides by 7, and we get x equals, now 71 divided by 7 we can do on our calculator, and you get 10.142857, and that's recurring, so the 142857 just recurs over and over again. But to make our life easier, we'll just leave that as an improper fraction, and that's a perfectly acceptable answer. Unless it tells us give our answer as a decimal, you can just leave it as an improper fraction or a mixed number, converting it like we did earlier on. A standard form is a relatively straightforward topic, but actually it's one that your calculator might be more of a hindrance than a help. It won't write these numbers in standard form for you, so you get 8.2 times 10 to the 4. You'll just have to remember how to do these, and this is 7.23 times 10 to the minus 3. Again, the 4 has come from 1, 2, 3, 4 digits after the 8, and the 3 here has come from your 1, 2, 3 leading zeros. I said earlier this could be a bit of a hindrance. If you put this into your calculator, if you use the older model, it actually just gives you back that as your answer, and it doesn't actually convert it at all for you. So you do need to be able to do these, because your calculator may just give you back the question the way that you put it in. It won't convert it for you. You can't press format and rechange it or anything like that. It just keeps it in standard form for you. So again, in this case, 3 jumps over those and then an extra 6 jumps. So we've got 6 zeros. So 8, 1, 6, 4, and then 1, 2, 3, 4, 5, 6 zeros. This one, 1, 2, 3, 4, 5 zeros, and then 7, 2, 2, and decimal point after the first 0. Where standard form and your calculator do work well together is in the bottom left and the bottom right hand corner. You can just do these calculations on your calculator and don't even convert them all, just put it all in one go in your calculator, and your calculator will do all of the work for you. What you'll have to do is put your answer in standard form at the end. So when I put all of this in my calculator, it gives me 450,000. So 450,000, which is 4.5 times 10 to the 5. This last one, again, put it into your calculator. And again, make sure we're reading that question carefully, because this says give your answer in ordinary form, not in standard form. So this just tells us our answer is 411,600. And then you can just leave your answer like that. It doesn't ask for standard form, so leave it as an ordinary form. Bounds and error intervals. Again, like I said, another topic that we looked at for paper 1. And again, calculator doesn't help massively on this one, but it does help you if you want to find the middle of two numbers. So we've got 4.3, our given value in the middle. To one decimal place, the number before that is 4.2, and the number after that is 4.4. The midpoints then are 4.25 and 4.35. So therefore the lower bound is 4.25 and the upper bound is 4.35. In the same vein, the next question, we do our little number line. 1,000 goes in the middle. To the nearest 10 means we go 10 above, which is 1010, and 10 below, which is 990. And we want to find the midpoint of those, which in this case is 995 and 1005. Now if you need help finding the midpoint of two numbers, all you do is add those two numbers and then divide by 2. So I would do 1,000 plus 1,010 is 2,010, divide by 2 gives me 1,005. So again, if you want to find the middle of any two numbers, add them together and divide by 2. Our error interval then is just 995 is less than or equal to V, the volume, which is less than 1005. Remember, the signs are always this way around, less than or equal to first, and then less than, and then we chose V because it was the letter given to us. Again, they were continuous values. If we look at the discrete values, it says Ella has £10.50 in pocket money saved to the nearest 50p. Work at the maximum and minimum. Again, we're going to use our number line to make life easier for ourselves. So £10.50 to the nearest 50p. So 50p above that is £11, and 50p below that is £10. So my upper and lower bounds then are £10.25 and £10.75. So the minimum she has is £10.25, and the maximum she has, and this is the important thing, when it's discrete, and we're talking about people, things, or money, we have to take 1 off the upper bound. So it becomes 10.74, because 75 rounds up and you can't have 74999. It doesn't go, it stops at 74, the next one is 75. So because it's a discrete value, you take 1 off at the end. In this question, we're calculating to find the upper and lower bound from a calculation. And so it's given that f equals ma and that f is this and a is this, work out the upper and lower bounds for m. So there's 3 things we need to do first. First thing we need to do is find the upper and lower bounds for f and a. So let's do that first. That's 295 and 305. And then for a, it's 17.5 and 22.5. The next thing is, because we're trying to find m, we need to rearrange this formula. So if we're to get m on its own, we're going to divide by a. So m is equal to f divided by a. Now you've got 4 options in combinations that you can do to work out m and try and figure out the lower and upper bounds. So if we look at all of those, you've got upper bound over upper bound, which would be 305 over 22.5. That gives us an answer of 13.5 recurring. We could do the lower bound over the lower bound, which is 295 over 17.5. Which gives us 16.857. So 16.857, etc. We could do the upper bound and the lower bound. So that would be 305 divided by 17.5, which gives us an answer of 17.428, etc. And then finally you could do the lower bound divided by the upper bound. So we get 295 divided by 22.5. So we're doing 295 divided by 22.5, and that gives us an answer of 13.1 recurring. And now you can see from this, well, our upper bound then must be this biggest one here. So our upper bound is 17.428. So let's just round that, 17.4. And our lower bound is the smallest one, which is 13.1. Upper bound 17.4, lower bound 13.1, because they're the biggest and smallest value. Now to save you having to do all 4 calculations, this table and this information here, again, as I showed in the first video, should just help you to do that. So the rule is start, so the numerator in each case is the value you're trying to find, and you divide by the opposite, or you subtract the opposite, or if you're adding or multiplying, you just match them. So use both the upper bounds or both the lower bounds. Now, these questions ask you to simplify, and in the first 2, it is very tempting to just turn around and go, oh, well, I'll just put it in my calculator. But if you put that first in your calculator, it just gives you 4. Now 4 isn't the simplified answer. 4 is what we call evaluating or working out the answer. It's working out the numerical value. When we talk about simplify, we mean write it as a single power of 2 and keep your indices. So in this case, we're just subtracting the powers, so we end up with 2 to the power of 2. Remember, we don't multiply the 2's. The 2 is the base, so that stays the same. And we just add the powers, and minus 6 plus 8 is 2. And this is where your calculator can really help you. Okay, if you're not confident with negatives, you can just use your calculator for that. Same idea here. We're not doing 8 divided by 8. We keep 8 as the base and we just subtract the powers. 4 take away 7 is negative 3. If you want, you can write that as 1 over 8 cubed, but I would recommend this as your answer. If they ask you to evaluate it, then you can put in your calculator to work it all out for you, but because they're asking you to simplify, that's what you have to do. Now, to stop you from using your calculator, they will often say, well, let's do this one instead. However, you can use your calculator because this 4 is not the base. The x is the base. So the 4 is a coefficient, so you have to do 4 to the power of 7. And again, your calculator will help with that bit. 4 to the 7 is 16,384. And then with your powers, you just multiply those two powers. 4 times 7 is 28. Now, they're not going to give you a question that complex in your exam. However, I was doing it to highlight the point here that your calculator can work for the coefficient part, but not for the next part. In this one, Our x's are our bases, so we can just take those away from each other. We get x squared. And now we're thinking, well, what does this 20, 18, and 27 do? Because 27 doesn't go into 18. Well, let's put 18 over 27 into our calculator, and that simplifies down to 2 over 3. So we can change this into 2x squared over 3. Because that's just simplified the fraction for us. We didn't need to think about how it happened. The calculator did all the work for us. Now, speed, distance, time, again, is another topic that's quite common, and it's just worth being aware of. Now, you will often be told, well, speed is distance divided by time. You might see this triangle. We might remember speed equals distance divided by time. I like to think of speed slightly differently, and speed is the distance covered in a set unit of time. So in this case, I'm doing 37 miles in 15 minutes. And I'm trying to find the average speed of the car in miles per hour. Well, in an hour, there's 60 minutes. So all I'm doing here is I'm timesing by 4. Okay, so 37 times 4 gives you 148 miles, which means that the car is traveling at 148 miles per hour. Okay, now obviously that's quite a fast speed, not very realistic, but again, for the object of this, it just shows you a way that you can lay it out. Now, the same thing happens in this one, when we're given the speed. Well, if we're given the speed of 70 kilometers per hour, that's 70 kilometers in 1 hour, which is 60 minutes. I like to work it into minutes, just makes life a little bit easier. And then we're going, okay, well, I want 62 kilometers. So I want to know, well, how long was I driving to for 62 kilometers? And again, we can use that scale factor idea from before. Multiply by 62 over 70. Again, doing the same on the other side, times 62 over 70. 60 times 62 over 70 gives you an answer of 53.1. Okay, so therefore to the nearest minute is 53 minutes. Third one then, a golf ball is hit from the tee and travels an average speed of 54 meters per second. So that's 54 meters in 1 second. And it travels for 3.8 seconds. How far did the ball travel? Well, we can quickly see here, well, we've just times by 3.8. So do the same on the other side, times by 3.8. 54 times 3.8 gives you a distance of 205.2. 205.2 meters. So 205.2 meters. So again, setting them up as like that equivalence helps make your life a little bit easier. Similar method can be used here for density, mass, and volume, or the nice thing about the units is grams per centimeter cubed. Grams per centimeter cubed, that's density. Well, this is a mass, and this is the volume. So therefore that tells you the formula is density is equal to mass divided by volume. Now what you have to be careful with is sometimes they will give you this and they'll say please state the units for your answer, so they don't give you that hint there, so you have to remember that formula, density equals mass times divided by volume. But if you can remember that it's grams per centimeter cubed, you'll always remember your formula. And then the advantage is then when you get to your answer and they ask you to write your units, you can get your mark for that as well. Now in this case we're combining a few things. So we're going to look at this. We're going to look at mass, volume, and density. And it's because we've got a couple of different things here. We've got iron is mixed with carbon to make steel. I'm going to set this up as a little table just to make our life a little bit easier. And let's fit in what we know. So iron has a density of 7.87. So iron density 7.87. Steel has a density of 7.78. So 7.78. 270 centimeters cubed of iron. Well, that's a volume, so that's 270 centimeters cubed. So we don't need the units. And then 5 centimeters cubed of carbon. So that's 5 in there. Work out the density of carbon. Now, when we've got these multiple things and we're mixing them together, whether it's materials, whether it's combining metals here to make steel, we are allowed to add the masses or add the volumes. The densities we have to work out separately, but we can add the masses or we can add the volumes. So because we're adding iron and carbon to make steel, we know that this is going to be 275 centimeters cubed of steel. Now, the next thing I can work out is, well, because I have these two values, I can work out the mass of the iron and the mass of the steel. So density is equal to mass divided by volume. So therefore, if I rearrange that formula, well, mass is equal to density times volume. So therefore, if I do 270 times 7.87, that tells me that I have 2,124.9 grams of iron, and do 275 times 7.78 for the steel, and that gives me 2,139.5. Now, as we said with the volumes, the iron plus the carbon gives us the steel, so if we subtract those two from each other, the steel take away the iron, that will give us the carbon, which is 14.6. The last thing we need to work out now is the density. And we know from the start density is mass divided by volume, so 14.6 divided by 5 gives us an answer of 2.92. 2.92. So the density of the carbon is 2.92 grams per centimetre cubed. Expanding brackets again can come up on any of the papers, and it can be in the middle of a question. It's just a skill just to make sure we're always confident with, and a calculator won't help us too much with, but it's really useful, particularly with the second one, which I'm going to show you. So if we expand this, 9 times 6 is 54x, 9 times 11 is 99, so we get 54x minus 99y. Again, if you're not that comfortable with your times tables, it doesn't matter. Pick up your calculator, let that do the work for you. Particularly where students make a mistake, and that's why I said the second one is working with negative numbers. So if you're not sure what negative 4 times 2 is, put in your calculator. Negative 4 times 2 is negative 8. Negative 4 times negative 8, well, that's, do two negatives make a positive? Use your calculator to check. That's plus 8 fours are 32. This is where it catches people lots of times. We've got minus and then a bracket. Well, what's actually there is a negative 1. And we're going to multiply that negative 1 into those. So that gives us minus 4x and plus 2, because negative 1 times negative 2 is positive 2. And now we're going to collect like terms. Remember, we're using the sign to the left. So minus 8x and minus 4x gives us minus 12x, and then 32 and 2 is plus 34 as our final answer. Similarly, expanding double brackets, we're going to multiply the 3x by both of the terms in the second bracket. So that's 12x squared plus 6x. And then the second term by both of them, minus 28x minus 14. Collecting like terms in the middle, again, if you're not sure, use your calculator. 6 take away 28 gives us negative 22x, take away 14. Now be careful, you can't put these x's into your calculator. The newer ones do have an x button on there, but it doesn't do anything. Okay, so well it does, but it doesn't do anything in this, and it'll likely give you an error. So just leave the x's out because it's not used for this purpose. In these questions we're looking at factorising. So expanding is taking out of brackets, factorising is putting into brackets. So we can take 4 out of each of these, which gives us 2x squared minus 5. And then that can't be factorised any further. That does look a little bit like the difference of two squares, but because 2 and 5 aren't square numbers, we just leave it like that. In the next one, we can take 3x out of both of these, and we get 2x plus 5y. And that's it fully factorised. Now the reason it's factorised fully is because you could have just taken out 3, or you could have just taken out x, but they're not fully. You have to take both the 3 and the x out. Finally, in the last one, we need to look at what number will divide all of those. Well, they're all in the 7 times tables, so we can factorise out 7. We can take an x out of each of those terms, and there's a y squared, y cubed, and y squared. So we can take y squared out of all of them. That leaves us with 2x squared in the first term, minus 5y plus 7, because we've taken the xy squared out of the last one. Forming solving equations is another important skill to be aware of. And this is here, the triangle below is isosceles, work out the perimeter of the triangle. Now, the interesting side of this is that because it's isosceles, that means that the two sides here are equal to one another. And we can do that algebraically by just letting those two sides equal one another. Now I always like to put the one with the bigger x on the left hand side. We're solving an equation with an unknown on both sides, so we subtract 3x from both sides. That gives us 2x plus 46 is equal to 12. Taking away 46 from, minus 46. So adding now 46 to both sides, you get 2x equals 58. And then dividing by 2, x equals 29. Then it asks us to work out the perimeter in centimeters. So what that means is we're going to substitute the 29 back in. So 3 times 29 plus 12. That's 99 on this side. Now, the other side should be exactly the same, but let's just check. And that's a good way for us to check our answer. That also gives us 99 when we sub it in. 5 times 29, take away 46. And the bottom one, 2 times 29, gives me 58. Then we add all of those together, 99 plus 99 plus 58. And that gives us the final answer of 256 centimeters for the perimeter. Now another way they could ask forming and solving equations is questions like this. So it says Paul has 3 siblings, Rachel, Shane and Daniel. Rachel is 4 years older than Paul. So because Paul is the first one, let's make him x. Rachel is 4 years old, so that's x plus 4. Shane is double Paul's age, so that's 2x, 2 times x, because double is multiplying by 2. And then Daniel is 6 years younger than Shane. Well, Shane is 2x, Daniel is 6 years younger, so minus 6. And it says the mean of their ages is 16. So to work out the mean, you add them all together and you divide by the number you have. So we had 4 here, so we've got, adding all those together, x plus 4 plus 2x minus 6 is going to give us 6x minus 2 divided by 4 would give us 16. We can then solve this. By multiplying by 4 you get 6x minus 2 equals 64. Adding 2 to both sides you get 6x equals 66. So x equals 11. Now the question asks what's Daniel's age. So we're going to sub 11 in there. And we get 2 times 11, take away 6. That's 22. Take away 6 gives us 16 years old. So our final answer is 16. Solving equations is another important part that it can appear very simply like this, or as we've seen before, as part of a bigger question. So just to quickly cover these ones, just for clarity, when we solve the first one, we bring the 11 across and we add it to both sides. We get 8x equals 32, and then dividing both sides by 8, we get x equals 4. The second one, we can do these two steps in one. We're going to multiply by the 3, 8 3s are 24, but then we're going to expand the brackets at the same time. It gives 20x minus 5. We can do those as separate steps, but it's just a little bit quicker to do it like that. Adding our 5 then to both sides, we get 20x equals 29. And then, like we did before, divide both sides by 20, x equals 29 over 20. And again, you can leave that as an improper fraction. If you want to check if you can simplify it, once again, put it in your calculator, that'll tell you whether you can or not. The next one, we're going to expand our brackets. So we get 7x minus 11 is equal to 27 minus 39x. Now what I like to do in these is I like to get rid of the smaller x. Now I know 7 is smaller than 39, but because that's negative 39, we're actually going to add 39 to both sides to make our life easier. Because again, we're trying to avoid using negatives. So that gives us 46x minus 11 is equal to 27. And now it's back to what we were doing at the very start. We add 11 to both sides, that's 46x is equal to 38. So x equals 38 over 46. Now we can't just leave the answer like that because that's not fully simplified. So again, put that in your calculator, 38 over 46, and that gives us an answer of 19 over 23. So x equals 19 over 23, and that's our final answer for that one. Rearranging formulae is very similar to solving equations. We're trying to make L the subject here. So first thing we're going to do is get rid of this t. So we get pt is equal to L squared plus c. Next we're going to get rid of all the non-L terms, so this c. So we get pt minus c equals L squared. And then finally, the opposite of squared is square root. So we get L is equal to the square root of pt minus c. Again, remember to be careful that you keep it, if it's lowercase in the question, make sure it's lowercase all the way through in your answers as well. On the right hand side, we've got two x's. We're trying to make x the subject. And these are the ones where you've got your subject term twice. And we're usually going to follow the same steps. So first thing we want to do is get rid of any brackets, any fractions, anything like that to make our life easier. So we're going to multiply the y by the denominator. That gives us 3y minus 2xy is equal to 5x minus 7. Then we're going to rearrange to group our x's together. I'm going to move my x's to the right hand side and my non-x's to the left, because again I want them to be positive. So this 3y hasn't moved. I'm going to put my equals back where it was. This negative 2xy is going to go to the other side of my equals and become positive 2xy. The 5x can stay on the right hand side, and then this negative 7 moves across the equal sign, so it becomes the inverse, which is positive 7. Then, because we've now got our two x terms together, we can just factorize out our x. So x bracket 2y plus 5 and 3y plus 7. And then to get x on its own, we do 3y plus 7 divided by that bracket, which was 2y plus 5. And that's our final answer. So that is equal to x. So let's line that up a little bit better. Now the other answer you could have got if you brought all your x's to the left hand side, and this is equivalent, you would have had minus 3y minus 7 over minus 2y minus 5. As long as all four terms have the opposite signs, so they were all positive in my answer, if all of your answers are negative and you had a positive x, then you know that you've got that correct. Okay, so you can bring it all to one side, take out your x, and then depending on what side you bring it on, you might get all positives or all negatives, but they're both equivalent. Again, equation of a line was in our first video, but it's worth, again, just recapping over that. So we find our gradient first, so m equals 7, and then we're going to sub that into our equation y equals mx plus c. This is x, this is y, always in that order. So therefore 9 is equal to 7 times negative 4 plus c. 9 is equal to negative 28 plus c. And then adding 28 to both sides, you get 37 is equal to c. We have c, we have m, put it into our final form of y equals 7x plus 37, and that's the equation of our line. Same idea with the next one. The first thing we need to find is m, but in this case we're given 2 points. Remember, m is the change in y over the change in x. So therefore the change in y, how did I get from 3 to 15? Okay, well that gave me add 12. And to get from 8 to minus 4, I've taken away 12. So m in this case is negative 1. And now we do the same thing we did in the left hand side. We can pick whichever point we want, so I'm going to use the first one because there's no negative numbers. And I get y equals mx plus c. Subbing in y is 3, m is minus 1, x is 8 plus c. 3 equals minus 8 plus c. Adding 8 to both sides, c is 11. Final answer then is y equals minus 1x plus 11, or if you want, just y equals minus x, you don't need the 1, plus 11. Two more of these is finding parallel and perpendicular equations. Now parallel just means the same gradient. So I know my line is going to be y equals 7x plus c, because that 7x is going to stay the same. So subbing in my point then, minus 2 is equal to 7 times 6 plus c, minus 2 equals 42 plus c, so c equals minus 44. So the equation of my line is y equals 7x minus 44. Now sometimes I'll say hence find the x-intercept of the new line. We know the y-intercept is minus 44. The x-intercept is when y equals 0. So we can sub that in. 0 equals 7x minus 44. So when we rearrange that, 44 is equal to 7x. Dividing both sides by 7, you get 44 over 7 is equal to x. So therefore the x-intercept is 44, 7, and 0. That's the point where it crosses the x-axis. The next one, find the equation of the line is perpendicular to that. So my gradient here is minus 2. So my perpendicular gradient, I use the negative reciprocal. So m2 would be, well, the reciprocal of 2 is a half, and we just change the sign to make it positive a half. So therefore we've got y equals a half x plus c, and then we sub in our point. 8 is equal to a half times 14 plus c. 8 is equal to 7 plus c, so c equals 1. So my equation then is y equals a half x plus 1. Now, plotting graphs can also come up, and usually it comes up in the form of, we're going to put this into a table. Now in this case we just have to substitute each of the x values in to find our y values. Again, your calculator will help you with this, and just remember to always use brackets when you're substituting in a value. So 2 times negative 2 is negative 4, take away 1 is negative 5. Subbing in minus 1 gives us minus 3, minus 1, 1, and 3. Then we can just plot each of these points. So minus 2, minus 5, there's our first point. Minus 1, minus 3, again being as accurate as we can. 0, minus 1, 1, 1, and 2, 3. Then we can just take our ruler and we just join those up in a nice straight line. So that's a nice equation of a straight line. In this one, again, similar idea, but in this time we have a quadratic. And it's good to know what these shapes should look like. A quadratic should look a bit like a U shape, so that's what we should expect from this. Again, using our calculator to sub in these values to make our life a little bit easier. Sub in minus 1, so that gives us 1 plus 3 is 4 plus 2 is 6. Sub in 0, that gives us 2. Sub in 1, that gives us 0. Sub in 2, that also gives us 0. Sub in 3, that gives us 2. And sub in 4, and we get 6. And you'll often see that this will happen. It'll repeat the pattern. So therefore, if we go to minus 1 and 6, 0, 2, 1, 0, 2, 0, 3, 2, and 4, 6. Now, we need to be conscious because these 2 points are side by side, so therefore we need to make sure we don't just flatten out the bottom of this. We want to come down with our nice curve, and then we want to dip just a little bit below that before we come back up, and then as we continue that back up, and we're going to just adjust that, because again we have to make sure we go through all of our points correctly. Take your time, and this is why we should draw in pencil. If we make a mistake we can rub it out, and that would be our answer to this one. So again, subbing each value in, plotting your points, and join them up, and knowing what shape it should look like, that this one was a quadratic, really helps. The second common type of sequence that you get, and the one you have to find the nth term for, is a quadratic sequence. So in a quadratic sequence, if we look at our differences here, that's 4, 10, 16, 22. Now that's not the pattern we would expect. However, if we look at the second differences, we get 6 each time. So therefore that means we're on our second difference. Now in the paper 1 video I did show 2 methods to do this, so please feel free to go back and watch it in that one. But in this one I'll just show you one method, which is what I like to call the step back method. 4 take away 6 is negative 2. And then here, being careful with our negatives, 6 take away minus 2 gives us 8. Then we have to remember C, A plus B, and 2A. So now we need to figure out A, B, and C. Well, 2A is 6, so therefore 1A is 3. 3 plus something gives me minus 2. Well, that's 3 take away 5 gives me minus 2. And then C equals 8. So then my nth term is 3n squared minus 5n plus 8. Now to check my answers are correct, I could sub in 1, and if I sub 1 in for n, I will get an answer of 6. If I sub 2 in, I'll get 10. If I sub 3 in, I'll get 20. 4, 36. Sub in 5, I get 58. So I get the answers I would expect when I sub in each of those values. Now identities are these ones where you've got this kind of triple equal sign. That just means that the difference between an equation and an identity. Equation is true for one value of x, or maybe two depending on the equation, and identity is true for all values of x. There's a few different ways to do this, but the way that I recommend you do is expand all brackets first, just makes life easier. So you get 3ax squared plus 15x plus 3c plus plus 6 is identical to 12x squared minus 3x plus bx minus 21. Now what we're going to do is we're trying to find a, b, and c. So we're going to bring all our a's, b's, and c's to one side and all of our non-a's, b's, and c's to the other side. So I'm going to put my a's, b's, and c's on the left hand side. So this first term has an a, b, and a in it. So I'm going to leave that there. This plus b on the right hand side is going to move to the other side, so make that minus bx. And this 3c can stay here as well, so plus 3c. And that's identical to 12x squared minus 3x. This 15x comes across and becomes minus 18x minus 21, and this 6 becomes negative 6. So tidying that up by collecting like terms, we get 12x squared minus 21x minus 27. Now we can start comparing them. If I look at our x squared terms, well, that tells us 3 times something x squared. Well, it gives us 12, so therefore 3a equals 12, so a must be 4. Looking at our b, negative bx is negative 21, so negative b equals negative 21, so positive b must be positive 21. And then finally, to finish off, 3c is equal to minus 27, so 3c equals minus 27, so c equals minus 27 divided by 3, which is minus 9. So a is 4, b is 21, and c is minus 9. There are a few other ways to do it, and you might have spotted the 4 straight away when you looked at it, but if you did it a different way, you should still get the same answer. The next step we're going to look at is factorizing quadratics. Now in paper 1 we saw quadratics where it was just x squared as a single value. Now we've got numbers where there's a value of a, so we call these non-monic quadratics. So these are going to be done slightly differently. So the first thing we're going to do is we're going to multiply a by c, so 8 times 7, which is 56. We're going to look at the factors of 56, so that's 1 times 56, 2 times 28, 3 doesn't work, you get 4 times 14, 5 doesn't give you an answer, 6 doesn't give you an answer, and then 7 times 8. And they're all the factor pairs of 56. Now we want them, because of this minus here, we want them to subtract to make 26, so that's going to be our 2 and 28. So we can open up our double brackets, we're going to put 7x into each of those brackets, and we're going to have minus 28 and plus 2 to give us our minus 26. Then to finish off, we can just divide one of our brackets by 7, which is going to be our first one in this case, and we get x minus 4 and 7x plus 2. Similarly, in the second question, we've got 12 and 2, but this one works out slightly differently. When we multiply our 12 times 2, we get 24. Our factors of 24 then are 1 times 24, 2 times 12, 3 times 8, and 4 times 6. Again, we've got a plus here, so we want them to add to make 11. So in this case, it's 8 and 3. Because it's minus 11, they're both going to be negative. And we get 12x minus 8 and 12x minus 3. Now, obviously, the problem with this is that you can't divide either of those brackets by 12. But what we can do instead is we can divide the first bracket by 4 and the second bracket by 3. And 4 times 3 gives us the 12, which is our a value, which is what we have to divide by. That then gives us 3x minus 2 and 4x minus 1. And that's our final answer for that one. Now this time we're going to look at solving quadratics. Now we can usually solve quadratics by factorizing. If we look at this first one, we've got to find the factors of 30 that are going to subtract to give us minus 13. So the factors of 30 are 1 times 30, 2 times 15, 3 times 10, and 5 times 6. And then to subtract to make minus 13 are going to give us our 2 and 15. So we get 3x plus 2 and 3x minus 15. Or we can write those in reverse order if we wish. We then need to divide one of our brackets by 3 because 3 was the value of a. Dividing the second bracket by 3, we get 3x plus 2 and x minus 5 equals 0. Solving that then, on the left hand side we have x is equal to, the opposite of plus 2 is minus 2, and the opposite of multiply by 3 is divide by 3. So we get minus 2 over 3, and then on the right hand side x equals 5. And there are two solutions to that quadratic. The second question looks very similar, however it's not equal to 0. And to solve a quadratic we must rearrange it to make it equal to 0. So if we start by rearranging this, we get 2x squared minus 11x plus 12 is equal to 0. And then we just do exactly what we've done before when factorizing. Factors of 24 are 1 times 24, 2 times 12, 3 times 8, and 4 times 6. We need them to add to make negative 11, so that's going to be 8 and 3. So we get 2x minus 3 and 2x minus 8 equals 0. And then solving that, sorry, before we do that, remember we have to divide by 2. So we divide the second one by 2, and we get 2x minus 3 and x minus 4 equals 0. We then separate that out. X equals 3 over 2 and x equals 4. Now in this third question, they won't always be factorizable, and a big hint you'll get on the calculator papers is they'll say it's 2 decimal places or 2 significant figures. This implies you're going to use the quadratic formula. Now the advantage is that the quadratic formula is given to you on the formula sheet, but it's the formula minus b plus or minus the square root of b squared minus 4ac all over 2a, and you can just substitute into that. What often confuses people is this plus or minus part here, and that just means you're going to do the calculation twice, once with the plus and once with the minus. The other error people make is they bring the wrong values. So in this case, a is the coefficient of x squared, so it's the number before the x squared, so that's your a. B is the number before the x, and then c is the number on its own. So b is 6, and c is not 12, c is negative 12. And that's a mistake students often make. They forget to bring the negative sign with them. Now anytime you substitute into a formula, you should always put brackets around your values. So we're going to have minus 6 plus or minus the square root of 6 squared minus 4 times 5 times minus 12 all over 2 times 5. And then we can just put that into our calculator twice, once with a plus here and once with a minus. And we get the answers of minus 2.26 to 2 decimal places and 1.06. Now you don't have to factorize, you can always use the quadratic formula if you wish. It'll give you your integer values, so instead of thinking about all that worrying about factorizing, if they just say solve it, you can just rearrange to make it equal to 0 and then use your formula every single time. Now this is a common place that you'll find errors in your calculator, and there's 2 errors you often get. The first is you get what's called a math error. Usually what happens in that case is you've missed one of your minuses on your C value, or you've missed out brackets on your value of B if it was negative. The other error you often get here in your calculator is a syntax error. And if you get a syntax error, what that usually means is you've either missed one of your brackets under your square root, or you've missed the bracket on the bottom of your fraction. Okay, so syntax error means you've missed a bracket. Math error usually implies that you've missed a negative value. And the next topic is algebraic fractions. And in the paper 1 video, we looked at simplifying algebraic fractions. In this video, we're going to take a step further and look at solving them. Now, the easiest way to solve questions involving algebraic fractions is to do the simplification part first, and then worry about the value on the right-hand side. So in the first question, we're going to ignore the equals 9 for a moment, and we're just going to start by factorizing this. Because remember, when we factorize these, they should usually cancel down and make it a little bit easier for us. So again, this is a non-monic quadratic. So we can use the same thing as before. 3 times 12 is 36. And we look at our factors of 36. That's 1 times 36, 2 times 18, 3 times 12, 4 times 9, and 6 times 6. And we're trying to subtract to make 5. So it's going to be 9 and 4. So then I like to do on the side. So it just keeps your work nice and tidy. So you get 3x plus 9 and 3x minus 4. And then dividing by 3 gives you x plus 3 and 3x minus 4. So the top of my fraction gives me x plus 3 and 3x minus 4. The bottom of my fraction is just the difference of squares. So square root of 9 is 3, so 3x. Square root of 16 is 4. So 3x minus 4, 3x plus 4. And that's equal to 9. We can simplify that down then, and we get x plus 3 over 3x plus 4 is equal to 9. And now we can just solve that. We can bring the denominator across and multiply by 9. And we get x plus 3 is equal to 3 times 9 is 27x, and then 4 times 9 is 36. Rearranging that to solve, we can take away x and bring it to the right hand side, and we can subtract the 36 and bring that to the left hand side. And we end up with minus 33 is equal to 26x. Then we can just divide both sides by 26. And we get x is equal to minus 33 over 26. Now, can that be simplified? Well, we can just put it into our calculator and check, and it doesn't simplify, so that's our final answer. Similarly with the second one, when we're adding fractions, we must have the same denominator. So in this case, we're going to make the denominator 28, because 7 times 4 is 28. And then we're just going to multiply the top over here by 7 and the top over here by 4. That gives us 7x plus 21 plus 4x minus 20 is equal to 2. Collecting our like terms then, we get 11x plus 1 over 28 is equal to 2. And now we can solve this. We bring our 28 across and we get 11x plus 1 is equal to 56. You get 11x, take away 1 gives you 55, and we can divide both sides by 11, and that gives us a nice simple answer of x equals 5. Our last question, because we've got algebraic denominators, we can do the same thing. We're going to combine our two denominators. So we're just going to have x plus 3 and x minus 2, and then we're going to cross multiply the 5 times the bottom right, so that's 5x minus 10, and the 8 times the bottom left, so plus 8x plus 24 is equal to 1. We can then collect like terms here and we get 13x plus 14. And before I said we don't need to expand the denominators. When we're solving, I do recommend that you expand the denominator. So if we expand the brackets, we get x squared plus 1x minus 6, and that's all equal to 1. And now we do what we did in the left hand side. We're going to multiply across by our denominator, and we get 13x plus 14 is equal to, luckily we're only multiplying by 1, so that just means our denominator comes across and doesn't change. And now we're going to rearrange this to get a quadratic, because it's a quadratic, it needs to equal 0 like we said before. We get x squared minus 12x and minus 20 equals 0. Sorry, I should say 20. Now we have to know, are there fractions of 20 that subtract to make 12? Well, 2 and 10, they don't subtract to make that. So let's look at our fractions of 20 to help us out. 1 times 20, 2 times 10, 4 times 5. Now none of those work, which means therefore we're going to have to use the quadratic formula again like we've seen before. And using the quadratic formula will give us an answer of x equals 13.5 or x equals minus 1.5. Again, that's just using our quadratic formula like we did in the last questions. Now, algebraic proofs tends to be seen one of those more difficult topics, and really once you understand the basics of how to represent these numbers, it does make it a little bit easier. So in a very simple sense, if we want to represent a number, we just call that n. If we want an even number, we represent that as 2n, and an odd number, we use 2n plus 1 or 2n minus 1. So this tells us to prove the difference, so difference means subtract, between two consecutive odd numbers, so consecutive means one after the other, one after another. Odd square numbers is always a multiple of 8. Okay, so we're going to look at our consecutive odd numbers. So we've got, well, we've written two of them here, 2n plus 1, 2n minus 1. So we're going to do 2n plus 1 squared and 2n minus 1 squared. And we're going to find the difference. We're going to subtract those two from each other. So that's the difference between two consecutive odd square numbers. So if we square the first bracket, and again that just means we're doing 2n plus 1 times 2n plus 1, and similarly the second one is 2n minus 1, 2n minus 1. If we square that, that gives us 4n squared plus 4n plus 1 minus, now we're going to leave the brackets here for a moment because this negative is going to expand into all of these values. It's technically like having a negative 1. That gives you 4n squared minus 4n plus 1. When you expand your negative 1 in, then you get 4n squared plus 4n plus 1 minus 4n squared plus 4n minus 1. And then when you collect like terms, the 4n squared minus the 4n squared cancel each other out. The 1 minus 1 cancel out, and we just end with 4n plus 4n is 8n. And we wanted to prove it's always a multiple of 8. So 8n just means 8 times something. So that's our answer proven. So we can just say always a multiple of 8. Similarly, if they wanted us to prove that it was always a multiple of 2, you could just factorize 2 out of your final answer and show it's 2 bracket something, and then it's always a multiple of 2. Now, similarly in this question, we want to prove the sum of 3 consecutive square numbers is always 2 more than a multiple of 3. So again, we're going to look at our square numbers. So the first one is n squared. The next one is n plus 1 squared, because that's our next consecutive number, it's 1 more, and then n plus 2 squared. And the sum just means to add all of those together. So let's do that manipulation. N squared plus, expanding our brackets, we get n squared plus 2n plus 1. And then if we expand our second brackets, we get n squared plus 4n plus 4. Tidying this up then by collecting like terms, we get 3n squared plus 6n plus 5. Now it wants to prove that this is always 2 more than a multiple of 3. And a moment ago I said that if we want to prove it's a multiple of 3, we have to factorize out the 3. But we can't factorize 3 out of this expression. But it's 2 more than that. So what we're actually going to do is we're going to split this final 5 into a 3 and a 2. So that's plus 3 and then plus 2. So all we've done is change this plus 5 into plus 3 and plus 2. Then these first 3 terms you can factorize out 3. And you get n squared plus 2n plus 1, which is a multiple of 3, and then plus 2. And that shows that it's always 2 more than a multiple of 3. The next topic is simultaneous equations, and this gives us a word problem that we can convert into a simultaneous equation to then solve. Now I like to convert my values into x and y. You can use t and s, you can use any letters you want, but I just like to always use x and y. And I put them above here just to remind me which one each one is. So my first equation is 4x plus 3y is equal to, and I like to convert this into pence, so 1525. And then the second one, 5x plus 4y is equal to 1950. Now we need to make either the x's or the y's the same. I'm going to make the y's the same, so I'm going to multiply the first line by 4 and the second line by 3 to make them both into 12. That gives me a first equation of 16x plus 12y is equal to 6100. And the second line multiplied by 3 gives me 15x plus 12y. And then we multiply again that by 3, and that gives us 5850. Now because my 12y's are both positive, I'm going to subtract those from each other, and that tells me x is equal to 250. Now in this case that's 250 pence or £2.50, but we're going to leave it as 250 for now. We then take that x and we substitute it back into one of our two equations. I'm going to choose the first one, so I get 4 times 250 plus 3y is equal to 1525. That's 1000 plus 3y is equal to 1525. Take away 1000 on both sides, that gives us 3y is equal to 525. And then dividing both sides by 3, y equals 175. So therefore t, which was my x value, as I saw at the start, is £2.50. And a scone is £1.75. And that gives us our final answer. Now the other way you could be asked simultaneous equations, and often the more difficult way, is where you've got these nonlinear simultaneous equations, where you've got an x squared, or you've got a value that's this. It's either a quadratic or it might be a circle, but we've got this sort of expression. Now this second one is already in the form y equals something. We can rearrange this first one to get either x or y on its own. Now it's much easier here to get y on its own, and we get y is equal to minus 2x plus 4 when we rearrange that. Now because this equation equals y and the other equation equals y, we can just let those two equations equal each other. Now when I write this, I like to write my quadratic first, and then that's equal to minus 2x plus 4. And I can do that because both of them are y equals something and y equals something, so those two things must be equal. Now as we saw earlier, we've got a quadratic, we need to make it equal to 0 to solve it. So we get 2x squared plus 7x minus 6 is equal to 0. Now there's a big hint here, it says give your answer to one decimal place. That means again we're using the quadratic formula to find our x values. So a is 2,
B is 7, and C is negative 6. So therefore, minus 7 plus or minus the square root of 7 squared minus 4 times 2 times minus 6, all over 2 times 2. Now that's going to give me two answers. It's going to give me x equals and x equals. And again, we get those two answers from putting either plus or minus in each of those. So putting that into our calculator, again we'll do the plus first, and I encourage you to practice this as well as you're watching the video, so that way you can check that you're putting it into your calculator correct. Remember what I said before, if you get a syntax error, you've often missed a bracket. If you get a math error, you've often missed a minus sign. So in this case, we get two answers, x equals 0.7 or 0.71. But again, it only wants our answer to one decimal place. And the second answer is minus 4.2. And then underneath those, we're going to find the two y values. Now it's important that we keep those linked to each other, because this first x is going to be linked to this first y, and then the second x is linked to the second y. And we find our y like we did in the previous one by summing it into our equation. I recommend you always do the linear equation, because otherwise you end up having to square decimals, and it makes it a bit harder. So if we sub that into the other one, we get minus 2 times 0.7 plus 4, and then our first one becomes 2.6, and then the second we get minus 2 times minus 4.2 plus 4, and that gives us an answer of 12.4. And there's our two answers. And remember, our left two values are linked together and our right two values are linked together, so they must be grouped like that in your answer. Next we're looking at functions, and again, functions is one of those topics that can be relatively straightforward, but also can be quite complex, and it's just about understanding the notation. So the first one says, given those two functions, work out f of 3.7. Now that just means we sub in 3.7 for x. So therefore that's going to give us 8 times 3.7 squared minus 4. And we have a calculator, so we can just sub that straight in. 3.7 squared minus 4. And that gives us an answer of 105.52. Now the second and third question don't have a number in there, so we actually have to do some algebraic manipulation here. So this f of g of x is what we call a composite function, and we start on the inside. So because g is on the inside, it means we're substituting g into f. So we've got 8 times g of x, which is x over 2, squared minus 4. When we manipulate that a bit, we get, well, that's 8 times x squared over 4 minus 4. And remember, when we're multiplying by a fraction, we can divide by the bottom and times by the top. So 8 divided by 4 is 2. So that then gives us an answer of 2x squared minus 4. And that's f of g of x. And finally, we've got the inverse function of f. Now again, what I like to have is I like to think, well, what happens to my x when I sub in? And I've already done some substitution, so I know that. The first thing I do is I square it, then I multiply by 8, and then I subtract 4. So the inverse function does the opposite in reverse order. So it adds 4, it divides by 8, and then it finds the square root. So therefore f inverse of x is equal to, well, when I write my x, first thing I'm going to do is I'm going to add 4, then I'm going to divide everything by 8, and then I'll find the square root. And that's my inverse function of f. Now the next topic is iteration, and this can come up in a number of different ways. What we'll see in the next couple of questions after this, you'll see the kind of more traditional iteration questions. However, they can ask things like this, where they say, show that this equation has a solution between minus 2 and minus 1. That just means we're going to sub in x equals minus 2 and work out the answer. We're going to sub in x equals minus 1 and work out the answer. And I'll show you then how we can check if there's a solution between those. So subbing in minus 2, you get minus 2 cubed minus 5 times minus 2 squared plus 11. And putting that into your calculator gives you an answer of negative 17. If we do the same thing with minus 1, again just subbing minus 1 in instead of minus 2, that gives us an answer of 5. Now it asked us to show that it has a solution between those two, and it said is equal to 0. So therefore, because ours is 0 is in between those two values, therefore solution between -2 and -1. Okay, because 0 lies between those values of -17 and +5. Now the second one asks you to rearrange to get your iterative formula. Now usually when you get something like this, what you're going to have to do first, so I'm just going to write this down here to make it a little bit easier to see. So this is my original equation. What you're going to do is you're going to isolate the highest power of x, so in this case the x cubed term. So we get x cubed is equal to 5x squared minus 11. Now you can see here there's a division here by x squared over this, under this 11, and that's what we're going to do here. We're going to divide all of the terms by x squared. And when we divide them all by x squared, well, x cubed divided by x squared gives me x. The x squareds here cancel, that gives us 5 minus 11 over x squared, which gives us exactly what we expected here. We just have to change our notation to x plus 1 and x n. Now this is the more typical example of what you'd expect to see here. It gives you an iterative formula, it gives you an initial value and asks you to find an approximate solution, in this case to 2 decimal places, or it might say find x1, x2, x3. So I always recommend you start by writing x0 is equal to the value they give you, so -1. That way you can keep track of what x you're on. Then we have x1 is equal to, and we're going to substitute this -1 in there. So we're going to get 5 minus 11 over -1 squared. So again, using our calculator. Now it's important that we put this into our calculator really carefully so that we then have that perfect example in there. That gives us -6. Now even if we can do that without a calculator, which I'm sure many of you can, we're going to put in our calculator anyway. Because what we're going to do now is, we're just going to write x2 equals, and we're going to write the answer. What we're actually going to put into our calculator is we're going to change what we have written in there, and we're just going to change that -1 into ANS. So using that answer key, either on the bottom side of the equals, or it's over on the left hand side on the newer model. When you put that in there, if you go back there and delete the -1, and change for answer, that gives you an answer then of 4.69. Again, we don't need to go any further because it just says to 2 decimal places. We're now going to work at x3, and to find x3 all we have to do is press equals, and just be very careful that you only press equals once every single time, because that's where you'll start to make mistakes, because if you press it twice you will get 2 numbers further along. The next one is 4.46, again rounding to 2 decimal places. x5 is equal to 4.45. We seem to be getting closer to an answer here. x6 equals 4.44, and x7 is equal to 4.44. And because we've got this repeated value here, the approximate solution for x is, because it's got that same consecutive value, it's 4.44 to 2 decimal places. Now we did already cover proportion equations in the paper 1 video, but it's worth looking at them again here. And in this one we've combined both into a single question. So it says y is directly proportional to the square root of x. So that means y is equal to, directly means we're multiplying, so k x and then square rooted, because it's the square root of x. And then it said z is inversely proportional to y, so that means z is equal to k divided by y. And it says work out the value of z when x equals 31, and it gives you some of the pairs there that work. So let's work out each of these values of k. So in this first one, for the direct proportion, when x is 16, y is 42. So we get 42 is equal to k square root 16. So, well, that's 42 is equal to 4k. So divided by 4, k is equal to 10.5. So my first equation then is y equals 10.5 root x. That's these two done. Now using the next two, z is 14.2 and k divided by 5. Well, to get k, we just multiply across by 5, and we do 14.2 times 5, which gives us a nice answer of 71. So k is 71. So therefore this formula is z is equal to 71 over y. Now we can do an analysis. Work out the value of z when x is 31. So we're going to say y is equal to 10.5 square root 31. And then using our calculator for that, it gives us an answer of 54.46, etc. So we're going to say y is equal to 58.461, etc. Now what we're going to do is we're going to keep that stored into our calculator, and we know this y value is then going to be substituted into our z formula. So we're going to say z is equal to 71 over, and underneath we're going to write that 58.461, etc. Now I know it says 4615 in your calculator, that means it should round to 2, but because of that ellipses, it just means we haven't rounded that value. What we're actually going to put into our calculator though is we're going to write 71 over answer. We've kept that answer stored in there to make it a little bit easier for ourselves. So we write 71 over our answer, and we get 1.214, etc. Or to three significant figures, 1.21 as our final answer. Next we're going to look at some trigonometry. So in this case we've got right angle triangles, and the two things we can use is Pythagoras theorem or the trigonometric ratios. Pythagoras theorem is used when we have two sides of a triangle and we need to find the third side. And remember, the hypotenuse, which is the cross from the right angle, should always be the longest side. Like I've said before, I think we should use the square root of 13.7 squared and 11.3 squared. And because we know that this x needs to be shorter, because 13.7 is the longest side, we can subtract those from each other. And then we can put that into our calculator in one go. So 13.7 squared minus 11.3 squared, and that gives us an answer of 2 root 15 or 7.75 to 2 decimal places, centimeters. And that's smaller than the 13.7, so we're happy with that it logically makes sense. In this case, we've got trig ratios, we've got an angle, so we know it's going to be SOHCAHTOA and not Pythagoras this time. Again, opposite our right angle is our hypotenuse. Opposite to our given angle, so opposite that 39, that's our opposite. And then our adjacent is beside the angle or just the other side. So we need to use the hypotenuse because that's the side we're trying to find, and we need to use the opposite because it's the side we're given. So we need to use O and H, so in this case we're going to use sine. So sine of 39 is equal to the opposite over the hypotenuse, 9 over x. Now because x is on the bottom, this tends to be the one that causes the most confusion. But because x is on the bottom, you can simply swap the x with the sine 39, and you get x equals 9 divided by sine 39, and then we put that into our calculator and we get 9 divided by sine of 39, and we get 14.3. Now again, thinking, does that make sense? Is that a logical answer? Well, we expect x to be the largest side because it's the hypotenuse. It's bigger than 9, so we can assume that we've got that one correct. Now, similarly, we've also got non-right angle triangles. And because there's no right angles in any of these triangles, it means that our formula is out the window. We can't use the trigonometric ratios, and we can't use Pythagoras. We need different rules. Now, we're going to look at 3 rules here. We've got the sine rule, the cosine rule, and the area of a triangle formula. Now, the sine rule is used in a very specific case. It's when you've got a non-right angle triangle and you have a pair of values. That means you've got an angle and the side opposite it. And when you've got that pair, you can use the sine rule. Now the sine rule is on your formula sheet. It's a over sine a equals b over sine b equals c over sine c. What I like to do is I think of it as two fractions, and the unknown value, the thing I'm trying to find, goes in this top left position. Now because it's an angle, it's going to be attached to a sine. So that's sine of x over, I look opposite that, that's 8, and then I make the other fraction, which is sine 48. This is made of the pair that I know divided by 10. The reason I like my unknown to be in that top left position is because now my second step is always the same. I'm going to bring the 8 across and multiply the other side. So I get sine of x is equal to sine of 48 divided by 10 times 8. Now you can work that out and get it as a decimal, but I like to do it as quickly as I can. Do it all in one step. So I get sine of x, or I get x is equal to, again, the opposite of sine is sine inverse. And anytime you find an angle, you will use sine inverse over 10 times 8, and we can let our calculator do all of that in one go. So sine inverse of sine of 48 over 10 times 8. And again, be very careful here with your brackets. This is where another place you might make a syntax error. But this gives us an answer of 36.5 degrees. Now again, we want to check if that's a logical answer. Well, the thing here is that the bigger the angle you have, so in this case I've got 48, that's opposite 10. Because 8 is smaller than 10, we would expect our x value to be smaller than 48, because bigger angles are opposite bigger sides, or vice versa, bigger sides are opposite bigger angles. So because the 8 is smaller, the x should be smaller, which it is, so we can be happy with that. Now in the second example, where we're using the cosine rule, that's because we don't have a pair. We've got two sides and the angle in between. And there's only two specific contexts we'll use the cosine rule, which is when you've got two sides and what we call the inclusive angle, or the angle between them, or you've got three sides and none of the angles. It's essentially when you have a non-right angle triangle and don't have a pair. And then you're given the formula for this. You're given a squared is equal to b squared plus c squared minus 2bc cos of a. Now the important thing about this formula is that a and a are the side we're trying to find and the angle opposite it, or the angle we're trying to find and the side opposite. So this is big A and this is little a. B and c don't matter, so we'll just do 7 is b and 10 is c. Now we can sub all the values in. X squared is equal to 7 squared plus 10 squared minus 2 times 7 times 10 times the cosine of 37. Now this is a nice easy one for us because the x is already on its own. We're just going to now find the square root of this. 7 squared plus 10 squared minus 2 times 7 times 10 times the cosine of 37. X equals, and again, put all that into your calculator in one go. So 7 squared plus 10 squared minus 2 times 7 times 10 times the cosine of 37 degrees. And that should give you an answer of 6.098, etc. So we're just going to say x equals 6.1. Finally, we've got an area of a triangle. Now usually you'll be familiar with the formula of a half base times the height. That works if you've got the base and the perpendicular height. You've also got situations like this where you've got two sides and the angle between them. And again, this is very specific. It has to be two sides and the angle in between them. So the formula for this is a half AB sine C. This is A, this is B, and C is the angle between them. And it has to be the angle between the two sides, you know. So we've got a half times 5 times 8 times the sine of 71. And again, your calculator will do all the work for you. A half times half times 5 times 8 times the sine of 71. And that gives you an answer of 18.9 centimeters squared. Remember, this one's centimeters squared because we're working in area. Keeping along with area and circumference of a circle, we're going to look here very simply. Area of a circle is pi times the radius squared. In this case, we're given the diameter, so the radius is 7.1. So it's pi times 7.1 squared. Again, giving your answer to one decimal place. Again, I encourage you to use the pi button on your calculator. If you don't have one, check the front of your paper. Usually they say use 3.14 or 3.142, but check the front of your paper to see what level they want you to use pi to for your calculations. But if you're using the correct calculator, you should have a pi button on there. So it's 158 point to one decimal place 0.4 centimeters squared. Circumference in the same way is pi times diameter, and again these formulae are given to you on your formula sheet. So that's pi times 14.2, and then again using your pi button, pi times 14.2 gives you an answer of 44.6 centimeters. Remember, area is centimeters squared, circumference because the length is just centimeters. Same idea with this sector, part of a circle. We've got 114 degrees, so a full circle would be pi times 8.3 squared, but we don't have a full circle. We've got 114 degrees out of 360, because remember a full circle is 360. So it's the same formula you have, and you just think, well, what proportion of the circle do I have? Well, I've got 114 degrees out of 360 times, and then your area of the circle formula. So you're not given this formula fully, but you are given the area of a circle, and if you just remember it's the fraction that you should have, that'll give you your answer, which in this case is 68.5 centimeters squared. Perimeter, again in the same sense, we can do 114 over 360 times pi times the diameter, and again we're given the radius here, so the diameter is 16.6, and we can go, if we work that out, that gives us an answer of 16.5 centimeters. That's not our full answer, that's just the arc length, it's just this curved part of our circle. Okay, that's our 16.5. We need to add our two 8.3s on there. So we're going to have 16.5 plus 8.3 plus 8.3 gives the final answer of 33.1. And that's our perimeter. Remember to add those straight sides on for our perimeter, and that gives you your final answer. Volume, very similar. Again, like we said, we're given the area of a circle formula, we're given the volume of a prism formula, and a cylinder is just a circular based prism. So we're doing pi times the radius squared times the height. So that's pi times 3.7 squared times 10. And again, we're working to two significant figures this time. So straight away putting that into our calculator, pi times 3.7 squared times the height of 10 gives us an answer to 430.08. So to two significant figures, that means 1, 2, that's 430 centimeters cubed because we're working on volume. Same idea with the cone. Remember, a cone is a cylinder and we just use part of it, so it's pi times the radius squared times the height, and it's 1/3 of that. So it's 1/3 times pi times half 13 is 6.5 squared times the height, which is 24.2. Putting all of that into our calculator, 1/3 times pi times 6.5 squared times 24.2, and that gives us an answer of 1070.707. So to two significant figures, that's 1100 centimeters cubed. Now we could also be given a volume question backwards, where you're given the volume and you're asked to find one of the values. So in this case, we're given the volume of the sphere and we're asked to figure out what the radius would be. So the volume of a sphere, remember the formula is always given to you. It's 4/3 times pi times the radius cubed is equal to 310. Now, to make this easier, we're trying to isolate this radius cubed, so we can bring this whole thing over in one go. We can say that, well, the radius cubed is equal to 310 over 4/3 pi. And then again, the opposite of cubed is cube root, so we can say the radius is equal to the cube root of 310 over 4/3 pi. And because we have a calculator, that will do all the work for us. We just have to be very careful with how we write this. So the first thing we write in our calculator is we write cube root, then our fraction button. On top of our fraction, we have 310. On the denominator of our fraction, we press the fraction button again to get 4/3, and then we put our pi in beside that, and that should give us our answer, which in this case is 4.198. So we'll just say the radius is 4.2. Now we want to check that we're right, so what we're going to do is just go back and we're going to sub that 4.2 back into our formula. 4/3 times pi times the radius, which is 4.2 cubed, and that gives an answer of 310.339, so that's close enough for us. So to two significant figures or the nearest whole number, that's correct, so we're happy that 4.2 is the correct answer. Now, angle facts, there's lots of different ways they can ask these. This is just a reminder of the key facts. This is a straight line, and that equals 180. If you've got an x, these are vertically opposite. And that equals, they're equal. This is around a point, So at a point, or a full circle, is 360. In a triangle, that equals 180. And then in a four-sided shape, which is a quadrilateral, that equals 360. And just knowing those facts will help you quite a lot. There are other intricate facts that you need to know about kites, parallelograms, trapeziums, but those are the kind of basic ones you need to know. The other angle facts you need to be aware of is obviously in parallel lines. Now, the key thing to remember here, even if you can't remember the names of the rules, there are only two angles. There's a big one and a small one. So if I call the big one a capital B, all of the big angles, as in bigger than 90 degrees, are all the same size if those lines are parallel. And all of the small angles, so we'll call them L for little angles, all of the L's are the same. Now, there are certain rules. The first one is that this one and this one, so I think of it in two halves. So if I put a line through the middle here, those two green ones are in the same position. This one's in the bottom right of the top section, this one's in the bottom right. If they're in the same position, they are corresponding. And they are equal, because you can see they're both B's. The second one you could have is, let's use a different color. Let's say this L here, that's in the top right. And then the opposite of that is the bottom left. So it's in the opposite position. If they're in the opposite position, they're alternate angles. And you can see they're also equal. So opposite position. And then these ones were same position. The final one then are co-interior angles. And these tend to be the ones that people don't mix up. And they sum or add to 180. Now interior means inside, so it means that this inside angle here and this inside angle here. So the other thing to remember is that all the B's are the same, all the L's are the same, and B plus L is always equal to 180 because it's on a straight line. Okay, and that should allow you to work out any of the angles even if you can't remember the rules. One of the last things to do with angles is angles and polygons. Now a regular polygon just means all the sides and all the angles are the same. Irregular polygon means the sides and angles aren't the same. Okay, now to find in a regular polygon, you could be asked to find the interior or the exterior angle. I always start with the exterior angle, even if I'm asked for the interior, because it's always 360 degrees divided by n, the number of sides. So in this question, I've got 1, 2, 3, 4, 5, 6, 7, 8 sides. That's an octagon. 360 divided by 8 is 45 degrees. That means the exterior angle, which is here, is 45 degrees. That's exterior. So the interior angle then makes a straight line. So you do 180 minus 45, which is 135 degrees. Okay, so the interior is equal to 180 minus the exterior. Obviously in an irregular polygon they're not all the same, so these don't work. But the other thing you could have, which works for both, is the interior sum. That's all of them added up. Now that's going to be n minus 2, remember n is the number of sides, multiplied by 180. So in this case, I've got 5 sides, 1, 2, 3, 4, 5. So I would do 5 minus 2 times 180, which is 3 times 180, which is 540. So therefore, if I add up 1, 2, 3, 4, 5, they will all add up to give me 540 degrees. The same thing would work on my regular polygon. As my octagon's got 8 sides, I would have 8 minus 2 times 180, which is 6 times 180. Okay, so that's 600, 648, that's 1080 degrees. I could have also done that with the 135 that I had, so 135 times 8, which also gives me 1080, and that's all the angles added up. So again, that's all you need to know about angles and polygons, and it should help you answer any question they ask. Now in this question we've got similar shapes or similar triangles, and we're just going to try and translate all the information that we're given onto the diagram. So the first thing, AB is 72, so this length from A to B is 72 centimeters. It then tells us that AC, so from here all the way down to here, is 1.5 times AB. Okay, well if we figure that out, that's 72 times 1.5, and if we do that we get 108. So this length is 108. Then we know the ratio of PQ to BC is 7 to 9. And because we know these triangles are similar, okay, because they've got parallel sides, and therefore the angles in, we know these are similar triangles. And that then tells us that this 7 to 9 is actually our scale factor. And that's true for any corresponding sides. So because we know the scale factor of the small triangle PQ to BC, so small to big is 7 to 9, we can use the same idea to figure out, well, if AC, the whole length is 108, that's going to be on the same as the big triangle, so that's going to be on this side, 108. What's our scale factor here? So 108 divided by 9, that means we times by 12. 12 times 7 is 84. That means that this smaller side, AQ, must be 84. Okay, because this scale factor is true for all corresponding sides. Therefore, to find QC, like we were asked to find, you're simply going to do 108 minus 84, and 108 minus 84 gives us an answer of 24 centimeters. The next step we're going to look at is travel graphs. And here you can see we've got a distance time graph, and it asks us to work out the speed in the first 10 minutes of the journey. So the speed in these questions is the gradient of the line. And we know that the gradient is the change in y over the change in x. Now naturally we want our speed in kilometers per hour rather than kilometers per minute. So we can work this out like we did before with speed, where we can say, well, in the first 10 minutes he's travelled 15 kilometers in 10 minutes. And remember, kilometers per hour means we want to get to 60 minutes. So we just multiply that by 6. And 15 times 6 gives us 90 kilometers. So our answer then is 90 kilometers per hour. And that would be our speed for the first 10 minutes. The next thing it says is he stopped to meet a friend for coffee. How long was he stationary? Now stationary is a horizontal line. So where you see the graph has gone horizontal, so between this point and this point, you can see that's where it's going to be. So it's between the 10th and 50th minute. So we do 50, take away 10 to give us 40 minutes he was stopped for. And then finally it says he drove faster in the first part of the journey compared to the last. How much faster? So again, we're going to find the speed for the final part, and we're going to do that in the same way. Well, we can see he's travelled for 10 minutes and he's gone 10 miles, or 10 kilometers, so 10 kilometers in 10 minutes. So therefore, in the same sense, 60 minutes is 60 kilometers. And then we had 90 kilometers per hour in the first part, 60 in the second part, so we end up at 30 kilometers per hour faster. Now the second question is a speed time graph rather than a distance time graph, and the other difference is that it's a curve rather than a straight line. So this first one asks us to work out the acceleration of the train after 60 seconds. So when it gives us a specific time, so after that rather than an average like you see in question B, when it asks for that after 60 seconds, that's what we call the instantaneous or instant acceleration. So we need to find 60 and we need to use the tangent. So we draw a tangent here, and we have to be as accurate as we can with this. And we should be using a ruler, a nice straight line, to get a tangent here. And then we're going to find the gradient of that line. So if we travel along here, travel up here, we can see that that's 5 seconds. And then up, we've gone from 30 to 40 to 4, so that's up 14. So if the acceleration is 14 divided by 5, which is 2.8 meters per second squared. Okay, so that's at that instant, so that's based on the gradient of that line. The next one asks us to find the average acceleration. So instead of finding a tangent, we have to find the line joining 0 seconds to 90 seconds. And we draw a line the whole way along from start to finish, again using a ruler. So this is the average, so it's a line joining 0, it's not a tangent. And then we find the average for the whole 90 seconds. So again, we use the same thing. We had 44 for the speed and 90 seconds. And then 44 divided by 90 gives us 0.48 recurring, or 0.49 meters per second squared. Question 3 asks, it says, use 3 equal strips to estimate the distance travelled. Now the distance is the area under the graph. So we're going to split this into 3 steps. So we're going to get rid of all these lines that we have here. You're unlikely to have all of these different questions on one graph in your exam, so you don't have to keep drawing over it, but each one could come up separately. So splitting into 3 equal strips, it's 90 seconds in total, so 90 divided by 3 is 30, so we split between 30 and 60. And we're going to find the area of shape 1, which is a triangle, shape 2, which is going to be a trapezium, and shape 3, which is also going to be a trapezium. Now when we estimate these, we're essentially going to join this line here, so it's going to be a little bit of an overestimate in that first section and be a little bit of an underestimate because it falls underneath there. So area 1 is going to be area of the triangle, which is a half the base times the height, so a half times 30 times the height of 6, and a half times 30 times 6 will give us 90 meters. Number 2 is a trapezium, so it's a half a plus b times h. So a and b are your heights here, and your height is the distance between those two lines. So we've got a half times 6 plus 30 times your height, which is 30, and that gives us 540 meters. Number 3 then, again, is another trapezium, so it's half, and then it's 30 for the height of the first part. Again, that will match the second height in shape 2 because it's a common, this side here is common between the two of them. And then the next height is 44 times the distance between them, which is 30, and then putting that into your calculator gives you 1,110 meters. So the total distance is all of those numbers added together, which gives us 1,740 meters travelled in those 90 seconds. Finally, it says, is your answer to question C an overestimate or an underestimate? In this case, it's actually impossible to tell. The reason it's impossible to tell is because in this section, we're overestimating. In this section, we're underestimating. And because we can't accurately measure those two curved areas, we don't know which one is bigger, so therefore it's impossible to tell whether it's an overestimate or an underestimate. But usually in these questions, they're either both an underestimate or both an overestimate, and then it's very easy to make your decision. Vectors is another one of those challenging topics that many students find difficult, and sometimes it's just about picking up some marks where you can, but we will look at how to find the final answer here. So it says, in the vector diagram, DC is 8a, that's already drawn for us, that's great. DA is already drawn for us. It tells us then that AD to DC, so AD and DC, sorry, AB and DC are in a ratio of 3 to 4, so that can be useful for us. So AB to DC is in a ratio of 3 to 4, and we can see DC is 8a, so our scale factor here is just times 2a. We can do the same on the other side, and that gives us 6a. So straight away we know A to B is 6a, and that's that piece of information done. And then the last one tells us that BE is 3/5 of AB. So this is 3/5 of what we just worked out. So we do 3/5 of 6a, and then dividing by the bottom and times by the top, or just using your calculator, you get 18 over 5a. So we're going to write this as 18 over 5a. It then says M is a point on BC such that BM is 2 parts and MC and BC is 5 parts. So we have to read this very carefully. BM to BC. So BC is the whole line. BM. So this is 2 parts out of 5. And this is 3 parts out of 5. And we have to be careful with that because this BC is the full length of the line. Sometimes you'll have BM to MC, but in this case that would have been 2 to 3, but BC is the full length. So just be very careful reading that and what it represents. Okay, so that's why it's 2/5 and 3/5. And then it's asking, is DME a straight line? Well, to check if DME is a straight line, we're going to find vectors DM, we're going to find vector DE, and we're going to check if they're parallel. So we don't have enough information yet to find DM, but we could find DE. So let's start with DE. DE, well, we're going to go up to A and then we're going to go across to E. So that's going to be A plus 3B plus 6A plus 18 over 5A. Now, often you'll think, well, I can't use my calculator for this, but you can. You can add the coefficients of A together. So 1 plus 6 plus 18 over 5. And that gives us an answer of 53 over 5A plus 3B. So that makes life a little bit easier for us. We've got that in a nice neat way. Then we're going to look at DM. Now we need to find BM or CM to work that out. So let's start with BC. So we're going to write BC. Now BC is minus 6A minus A minus 3B plus 8A. If we collect all those together, we get A minus 3B. And now to find DM, we're going to do A plus 3B, plus we're going to go AB, which is 6A, and then we're going to do 2/5 of that vector we just found BC, A minus 3B. Let's expand that first. So A plus 3B plus 6A plus 2/5 of A minus 6 over 5B. Again, we can use our calculator to collect our terms here. So we've got our coefficients. So our A's is 1 plus 6 plus 2 over 5. That gives us 37 over 5A. And then our B's are 3B. So 3 minus 6 over 5. And that's 9 over 5B. Now we can then see if we factorize DM, DM can be written as 1/5 times 37A minus 9B. And if we look at DE, we can see that they're not multiples of one another. If I divide my 9 by 3, you can see that's not going to work if I divide the 37 by 3 to get to the same answer. Okay, so we can tell then that DE is not parallel to DM. Therefore, DME is not a straight line. Because remember, for them to be a straight line, they have to be parallel to each other. And for them to be parallel, they have to be scalars of each other. So there has to be a common scale factor between the A values and the B values. And in this case, it isn't. Okay, so that tells us straight away, even easier to spot, we can see that our A's are positive and our B's are negative. So they can't be a straight line. So therefore, we can say that that's not a straight line. Now, looking at the topic of pie charts, it gives us some information. It says, when leaving a restaurant, guests are asked will they return for another visit. It says 4 times as many guests said yes as prefer not to say, and given that 540 people answered the question, how many more people said yes than no? Now, it might seem that there's not enough information there, but there's actually a key thing here on our graph, which is this square, which means that the no section is 90 degrees, and we know that a pie chart is out of 360, so 360 divided by 90 is 4. Or a better way to write that is you put your 90 out of 360, which tells us 1/4 of our pie chart is for no. So then we're going to find a quarter of 540. And again, we can find that in our calculator by just doing 1/4 times 540, and that gives us 135 for no. Then it tells us for yes to prefer not to say, it says 4 times as many. That just means the ratio is 4 to 1. So the number of people that includes is your 540 minus your 135, which is 405 people either said yes or said prefer not to say. We can then split that 405 into the ratio of 4 to 1. So 405 divided by 5 gives us 81. So our scale factor here is to multiply by 81 on both sides. And that gives us our answer of 324 to 81. Finally, it says how many more people said yes than no. So we're going to finish by doing 324 take away 135, and that gives us 189 people as our final answer. And the next topic is commutative frequency, and if you see this phrase commutative frequency, it just means you're going to find a running total. So that means we're going to add up each of those values as we go along. So we're going to add an extra column here, which is our CF, or our commutative frequency, and when we add these up we get 8 plus 32 is 40, add your 24 is 64, add your 12 is 76, and then add your 4 gives you 80. And often in the first line of this question it'll tell you 80 people were asked, so you can double check to make sure your commutative frequency is right. We then need to draw a commutative frequency graph for that. So we're going to put time always on our horizontal axis. And we can see that goes up to 55. So if we just check 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, that works. So we can just say 5, 10, 15, 20, and we can keep going. And what we need to be careful with is, like I did, just check to make sure it works before you start writing this, because what you don't want to do is get halfway through and then realize you've not given yourself enough space. Your vertical axis then goes up to 80. So I think this will work if we just go 10, 20, 30, 40, 50, 60, 70, and 80. And every little box then is worth 2 for us. Now, we're going to start our graph at 5, because 5 is our first value, so that's where we start at on our x-axis. And then we're going to plot the upper bounds with our commutative frequency. So at 15, we're going to go up to 8, which is here. At 25, we're going to go up to 32, which is here. At 35, we're going to go up to 64. At 45, we're going to go up to 76. And then finally, at 55, we're going to go up to 80. And we're going to join all these up with a smooth curve. Now you get a mark for those points being in the correct position. Okay, and you're allowed half a box of tolerance, so half a small box up or down. And in the same sense with this one, your curve needs to be the same level of accuracy. And you get a mark for this, so take a minute to do this, take your time. Do it nice and slowly, make sure it goes through all of your points. And as long as you, even if you get one of your points incorrect, if your graph goes through all of your points perfectly, you'll get your marks. And that's our commutative frequency graph drawn. It then asks us to work out the median and the interquartile range. So our median is half of our people. So the total is 80, so halfway then is 40. And we're going to come across. Now our median is not 40. 40 tells us where to look for our median. We're going to come across to our graph, and then we're going to come down to the axes. And we're going to say that lands on 27. So our median then is equal to 27. Our interquartile range, what we have to do for this, we have to do our upper quartile minus our lower quartile. Our lower quartile is going to be half of our median, so 20, or a quarter of 80. Again, we come across to our graph, and we come down to the bottom, and I'm going to say that that's 21. And then our upper quartile is halfway between the 40 and the 80, or you can just do the 20 plus the 40 to give us 60. And then come across to our graph, and all the way down. And that gives us an upper quartile of 33. So therefore our interquartile range is 33, take away 21, which gives us 12 as our interquartile range. And that's all we would need to do in that question. Now in this question we've got box plots, and we're asked to compare the performance between the two. So first of all, how we read a box plot. This line here represents our lowest value. And on the opposite end, that's our highest value. Importantly, the edge of the box here is your lower quartile, and the upper edge of your box here is your upper quartile. And then the line in the middle, even though it's not exactly in the middle, but that's always going to be our median. Now, when we compare box plots, we always compare two things. We compare the average, which is the median, and we compare the consistency, which is the interquartile range. Now, with the interquartile range, the key thing to remember is that smaller is better. We want a smaller interquartile range to be more consistent. So, looking at group A, we can see that the median is this middle value here, which we can see is 12.5. So let's put it all down here. So group A, we have a median of 12.5, and we have an interquartile range. And again, we're looking at our lower quartile minus our upper quartile. So that's going to be 20.5 minus 8.5 to give us 12. And group B, we have a median of, again, looking at the middle here, that's 17.5. And then our interquartile range, again looking our upper quartile minus our lower quartile, and our upper quartile for that is 21.5, and our lower quartile is 7.5. So that gives us 14 as our interquartile range. And now we can use the structure similar to this. We can say group A. So if we look at the average, the medians, it was lower. So group A had a lower score. Again, the context of the question is scores, a lower score on average. And then we can put the number in there, so that was 12 compared to group B. And they had 14. So right, we're looking at the medians, so that actually shouldn't be 12, it should be 12.5, and there should be 17.5. Again, looking at our medians. We don't want to say whether that's better or worse, we just want to say they had a lower score or higher score on average. The second one, we can say group B, or group A, had a, and if we look, 12 is lower, so a lower or smaller interquartile range, which is 12, compared to group B, which was 14. Meaning, and this is where we will add meaning to this, they were, now remember what we said, smaller interquartile range means more consistent. So because it's smaller, they were more consistent. And again, we can just vary that word more or less depending on whether the interquartile range is bigger or smaller. So again, when we're comparing box plots, we always compare the median, which is the average score, and the interquartile range, which is the consistency. But again, we want to avoid using the words better or worse. We use higher or lower, and then obviously a smaller interquartile range is more consistent. Now averages is the next one, and it's averages from raw data, and then we're going to look at it from a table as well. So in each case, the mode is the most common value. And we can see in this list of values, we've got 2, 4, 6, 7 values. So that's 14.4 is the mode because it appears most often. The median is the middle value, but they have to be in order first. So let's order these values. We get 9.2 first, then we get 11.3, then we get 12.9, 13.5, 14.1, 14.1, and 14.6. So then the middle value we can see is 13.5. The mean we'll work out in a moment, the range we'll do next, which is just biggest minus smallest. So that's 14.6 minus 9.2. And again, just putting that into our calculator gives us an answer of 5.4. The mean, remember we find the total divided by n. So it's always all the values added up divided by n, the number of values we had. So in our case, we've got 7 values, and we're going to add up all those numbers. So 9.2 plus 11.3 plus 12.9 plus 13.5 plus 14.1 plus 14.1 plus 14.6. And that gives us 89.7. Now we know that when we divide this by 7, our answer should be somewhere within our range of 9.2 to 14.6. And that's a way that we can check our answer. Now that gives us an answer to one decimal place of 12.8, which is within our range. It's between 9.2 and 14.6, so we can be fairly confident that that's correct. Just to do a second one, and again it's not massive on this one, but again we can see the mode is, it appears twice, 12.9. Now we're going to do the median. This is where it's slightly different. 8.1 plus sorry, not plus, we're going to put them in order, so 8.9, then we've got 8.1, then we've got 10, then we've got 12.3, 12.8, 12.9, 12.9, 14.9 and 15.6. So we should have 1, 2, 3, 4, 5, 6, 7, 8 values. 1, 2, 3, 4, 5, 6, 7, 8 values. Okay, the median then is the middle value. Now that's 1, 2, 3, 4, 1, 2, 3, 4. Well, the middle value then is between these two. It has to be exactly in the middle of those. So to find exactly in the middle of those two numbers, well, we can usually be quite good. You can see that, and well, that's 12.85. So that's our median, because we have an even number of values. If you can't see that, you just add those two numbers together. So you could have got that by doing 12.8 plus 12.9 divided by 2, and that will give us our 12.85. The mean and the range are worked out in exactly the same way as the first example, so I'm going to leave those for you to try. Now, averages from a table work in a slightly different way, because the table is just a way of tidying up. Rather than having loads and loads of numbers written beside each other, we can just tidy that up into a table. Now, the modal number of books, again, means the mode, the most common. But again, what we're going to look for is the highest frequency. And we looked at our frequencies and we see, well, it's this one. And it's the number of books borrowed. So the modal number of books borrowed here is 2 books. It happened 20 times, because this table means that 0 books were borrowed 8 times, 1 book was borrowed 14 times, 2 books were borrowed 20 times, 3 books were borrowed 18 times, 4 books were borrowed 8 times, and then 5 or more books were never borrowed. It then asks you to look at the median number of books. Now, for the median number of books, we need to find that middle person. Well, first of all, we need to know how many people there are. So if we add our frequencies up, so 8 plus 14 is 22, plus 20 is 42, that's 60, that's 68 people. So we're going to do 68 divided by 2, because we want to find halfway. 68 divided by 2 is 34. So we need to find the position of the 34th person. What I like to do is I like to write a running total on here. Cumulative frequency, like with our cumulative frequency, but I like to write it on the lines. So if we've got 8 there, 8 plus 14 is 22, 22 plus 20 is 42, plus our 18 gives us our 60, plus our 8 is 68. Now we can see that 34 lies in between 22 and 42. Therefore, the median number of books borrowed must be this section, so it's 2 books. Finally then, the mean number of books borrowed. So we need to find how many books were borrowed in total, and we're going to divide that then by 68 people, because that was the total frequencies. And the total number of books borrowed, remember I said that this first line means 0 books were borrowed 8 times, so that's 0 books. So we call this books total, for example. In this case, 1 book was borrowed 14 times, that's 14 books. 2 books were borrowed 20 times, that's 40 books. 3 books were borrowed 18 times, so 18 times 3 gives us 54 books. 4 books were borrowed 8 times, so 8 fours are 32, and then 0 for the last one as well. If we add all those together, 14 plus 40 plus 54 plus 32, that means 140 books were borrowed in total. Divide that by the 68 people, by the 68 occurrences, and that gives us an answer of 2.1 books per visit. Now again, I know you can't borrow 2.1 books, okay, but that's some of the drawbacks of using a mean. You might get a decimal answer that doesn't really make sense, but it just means on average people got 2 or a little more than 2 on average. Now taking this one step further, okay, we can do it when we've got these interval values. Okay, you can see instead of it being 0 books, 1 book, 2 books, 3 books, we've got between 0 and 4, 4 and 8, 8 and 12, 12 and 16, 16 and 20. We work this out in the same way though, we just write the class interval. So remember, modal means highest frequency, so the answer is just 8 to 12. Median is done in exactly the same way. We'll do our cumulative frequency or our running total. That's 11, 26, and that again, that's 40, that's 53, 75, and 80. Okay, so again, our median is half of 80. So we've got 80 divided by 2, which is the 40th person. And we can see the 40th person lies in here, which is again the exact same interval as the mode. And that's often the case in these questions. The mode and the modal class and the median class will be the same. It's not always the case, but it does happen quite often. The last question asks then to estimate the mean mass of the watermelons. And before, what we did is we took the number of books and we times it by the frequency. That doesn't work in this case because we've got 11 people. So let's in this first one, we've got 11 watermelons in that range of 0 to 4 kilograms. Okay, and we don't really know what value to use. The fairest value to use is the middle, or the midpoint. So we're going to find the midpoint of all these masses. Easiest way to find the midpoint is you add the two numbers and divide by 2, like we said earlier. So 0 plus 4 is 4, divided by 2 is 2. And if we keep going, you get 6, 10, 14, and 18. And the last column then, that's now our number, or this is like the equivalent of our number of books, and we times that by our frequencies. I like to call this the M times F column, our midpoints times our frequencies. So 11 times 2 is 22, 15 times 6 is 90, 27 times 10 is 270, 22 times 14 gives us 308, and 18 times 5 is 90. So then we can just add all those values together. So 22 plus 90 plus 270 plus 308 plus 90 gives us 780 kilograms. That's the mass of all of our watermelons. And in total we had 80 watermelons, so we divide that by 80. And again, remembering that our value should be somewhere between 0 and 20 because that's our range of values. And we get 9.75 kilograms. Now the reason it's an estimate is because we don't know exactly what weight each of those watermelons were. We've assumed it's in the middle. It could be below that, it could be higher. So the mean could be bigger than 9.75, but it also could be smaller. It's because we don't know the exact value. So again, the fairest way to estimate is to use that middle value. Capture recapture is a really interesting topic that can come up, and it's some easy marks for us to get if we just remember the simple layout to it. So the first part we're going to have is our first sample over the population is equal to the tagged, this is the way I like to remember it, over the second sample. And this will all make sense in a moment we go through it. And essentially we want these two to be the same proportion or the same fractions. So our first sample, well, if we look, she captures 20 Barnells. So we've got 20. We're usually trying to estimate the population, so we don't know what that's going to be. So we're just going to use a capital N for that. Then it says a month later she collects a second sample of 24. So our second sample is 24. And 8 of them are tagged. So we get 8 on top. And now we just need to solve this equation. And we can cross multiply here. So 8 times n is 8n. And 20 times 24 is 480. So I've just multiplied this number by this number, and this number by this number. And then to solve, we just divide both sides by 8, solving a simple equation, and then we get n equals 60. So we would estimate there to be 60 Barnells in the forest. And that's how we estimate our population using capture recapture. Looking then at two-way tables. Two-way tables is done quite a bit, and it's quite an interesting one to look at in terms of filling them out. It's about taking your time with these. So it tells us that 400 students are in total. So that total down here is 400 students. It then tells us 75 out of the 210 year 10s chose Latin. So that tells us that there are 210 year 10s and 75 of them chose Latin. 110 of the 200 students who study French are in year 11. So that tells us 200 students study French and 110 of those students is in year 11. So that's that information. And again, always concentrate on trying to fill in the information first. I know you can see some quick calculations you can do now, but we're going to fill in all the information first. Then it says 5/8 of the students who study Spanish are in year 11. There's nothing we can do with that yet. Okay, so we're going to have to remember to come back to that. So now let's figure out some of the information we can. We've got this gap here, so we can do 400, take away 210, and that gives us 190 students in year 11. We can also see that with French there was 200 students, 110 of them are in year 11, so that means there's 90 of them in year 10. That then allows us to figure out, okay, well, we can figure out year 10 Spanish now. So we can do 210 minus the 75 and the 90, and that gives us 45 students. And again, I've put the red in because that was the information that was given to us in the table. The green is then what we're working out. Now the next thing, it says 5/8 of the students who study Spanish are in year 11. That means that 3/8 are in year 10. So therefore 3/8 of Spanish is equal to 45. So 1/8 of Spanish, to simplify it down, is 15. So therefore 5/8, which is your year 11, is 5 times 15, which is 75. So this gives us 75 in here. And now we can finish this off. 75 plus 45, that gives us 120. 120 plus 200 is 320, meaning there's 8 students who study Latin. 75 plus 5 is 80. Now this 5 is the pivotal one that I always check from. I've done 75 plus 5 to give me 80, but working horizontally as well, let's just make sure that adds up. 75 plus 110 is 185, plus 5 is 190. So we know because it works in both directions, it works. Now you'll then be asked some follow-up questions like, what's the probability that a year 10 student studies Spanish, or what's the probability that a student who studies Latin is in year 11, etc. They'll ask you some key information about each of those. Again, but that's how you fill in the table, and then the rest is just reading the information that you need. Frequency trees then. If we look at frequency trees, these are relatively straightforward. They're quite a nice diagram to look at. And it's just filling in the information again, but it's just understanding the layout. So 500 people take a challenge. So that's 500 in my first box. There are 3 times as many under 18s as over 18s. So that's similar to what we saw before. That under to over is a ratio of 3 to 1. It then says, so under to over 18s, well, we can use that information. We can split that 500 into that ratio. So 500 divided by 4. So 500 divided by 4 is 125. So therefore there's 125 students over 18. And then 500 minus 125 gives us 375 under 18s. So there, that's our first 2 lines done. It then says 7/25 of the under 18s win the challenge. So we can find 7/25 by just doing 7 over 25 multiplied by 375. That means 105 win. So 270 lose. And then it says 180 people win in total. That means that my 2 win boxes should add to give me 180. And we've already got 105, so therefore only 75 of the over 18s win, which means that we've got 50 who lose. And that's our frequency chain drawn. Now, B says a person is chosen at random, so that's out of the 500, because it doesn't give me anything about the person, it's just a person. Work out the probability that they lose. Well, out of the 500 that played, 320 of them lost. So that's 320 as your probability. The next one says a person under 18 and over 18 are chosen at random. Who is more likely to lose? Well, if we do under 18, that's going to give me the probability of them losing is 270 over 375. And the over 18 is going to be 50 over 125. Now, how do we compare those? Usually we'd say, well, let's make the denominator the same. But because we have a calculator, we're just going to make that into a decimal number instead. So that gives us an answer of 0.72. And then 50 over 125 gives me an answer of 0.4. So who's more likely to lose? It's the under 18. Tree diagrams then, these are probability tree diagrams. They're slightly different to your frequency trees. And again, I'll go into it more in the paper 1 video, but let's have a look at this one and see as quickly as we can. So it says, Peter's taking part in a chess tournament. He wins the first game, he plays again. If he loses either game, he is eliminated. So if he wins, he gets to play again, which is a win and a lose. If he loses, he stops. So we then need to figure out what the information is that we're going to work out. So we can see the probability that he wins each game is 0.4. So for that 0.4, this is 0.6, and then it's the same in the second sense, 0.4 and 0.6. So that's our tree diagram completed. It then says, what's the probability that he wins both games? Well, that's just 0.4 times 0.4, and that gives us 0.16. The second one, we've got a box that contains 15 black socks and 12 white socks. Lloyd takes 2 socks from the box. Now when we do this, we have to take the socks one at a time. So in the first one, it's 15 out of 27 are black and 12 out of 27 are white. In the second choice, we've taken a sock out, so there's only 26 left in each of these. So my denominator changes to 26. And then if I've taken a black out, there's only 14 of those left and 12 of those left. But if I restart and take a white out, that means there's 11 white left and I'm back to 15 black. Then it says work out the probability that he chooses a matching pair. Well, that's 2 blacks. So that's 15 over 27 times 14 over 26. And that gives us 35 over 117. Or you can pick 2 white, which is 12 over 27 times 11 over 26. And that gives us 22 over 117. So therefore the probability of picking a matching pair is you add the two of those together, which is 57 over 117. And that's our final answer. One of the last topics we're going to look at is the product rule. And this is often about choices or making codes or options in a restaurant or a meal deal. So in this case, there's a meal deal. Customers choose a main, a side, and a drink. And in the deal, there are 15 mains, 10 of which are sandwiches, 32 sides, 13 of which are crisps, and 18 drinks, 9 of which are fizzy. How many different combinations of meal deal are there? Well, all we do in this case, we do 15 mains times 32 sides times 18 drinks. So 15 times 32 times 18. That gives us 8,640 different combinations. Then it says a meal deal is chosen at random. Work out the probability it's a sandwich, crisps, and a fizzy drink. Well, there are 10 sandwiches, 13 packets of crisps, and 9 fizzy drinks. So 10 times 13 times 9 gives us 1,170 different combinations. So our probability then is 1,170 combinations out of 8,640 combinations. And we can write that, we can leave that like that, or we can simplify it down if we wish. But again, you don't have to simplify probability. But again, because we have a calculator, we can make our life a little bit easier. And it gives you 13 over 96, or as a decimal, 0.135. Now this question asks us to do a Venn diagram in a slightly different way to what we had in the paper 1 video. The paper 1 video was about frequencies and they were in there. This is actually using the elements and the sets, and we have to put those values in there. So it says using the numbers 1 to 20, fill in the Venn diagram. So we're going to look at what are our even numbers. Well, our even numbers are 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. They all go in the even side. And the square numbers, well, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, but that's above 20, so we don't need to use it. Now when we fill in a Venn diagram, we should always start with the middle. So we're going to look and see, well, okay, 4 is in both lists, so that could go into the middle for us. And 16 is in both lists, so 16 is in the middle. The leftover square numbers go in the square side, so 1 and 9. And the leftover even numbers go in the left-hand side, in the even side. So we have 2, 6, 8, 10, 12, 14, 18, and 20. And then the last thing we need to do is fill in the rest of the numbers. So what we're missing is the odd numbers that weren't in there already. So we have 1, we don't have 3, 5, 7, we have 9, 11, 13, 15, 17, and 19. Now those last few numbers can go anywhere outside the circles, but they must be inside the box, but we usually put them in the lower right hand corner. It then says the number is chosen at random. So with our probabilities, we're always going to build the denominator first. There are 20 numbers to choose from. Work out the probability that it's even and not square. So even and not square is anything in this section here. So even and not square, well, that will tell us that the answer then is 1, 2, 3, 4, 5, 6, 7, 8 of those. So it's 8 out of 20. You don't have to simplify that, but if you want to, just put in your calculator and your calculator will simplify that for you. The next one says a square number is chosen at random. So our denominator is all of the square numbers. There are only 4 square numbers that are smaller than 20. So 1, 4, 9, and 16. Work out the probability it's also odd. So we're looking for the square numbers that are odd or not in the even section. So that's going to be this one and this one. So therefore we can see that's 2 out of 4 or a half or 0.5 if you wish. And again, that's how we would do a Venn diagram. Remember, with your probabilities, you should try and work out what would the denominator be first and then work out your numerator. The other way you could be asked Venn diagrams is shading. Now there's lots of different ways to shading. What I'm going to do in this case is just show you each of the answers. Okay, so A is just everything inside of A, so it would just be that section there. B with a little apostrophe means B complement, so that means not B. Okay, so it's everything outside of B, so it's all the way around here, and even the intersection is included because it has to be outside of B, so we do not include the intersection. This next one, the intersection, this means both, so it's in both A and B, so it's just this section. This one, the U, is union, but means either or both, so it's in any of the circles. So it's all the way through there. And it's just about knowing how to read those. Now we can take this one step further. The next level is where we start combining these complements with these unions and intersections. So this means in A and not in B. So if it's inside A and it's not inside B, it's just this kind of crescent moon shape here. So that's in A and not inside B. The next one is the same thing as says in A or not inside B. That's different. So we're inside A, which is all of this here. And then not inside B also includes this. So this does include the intersection. Now that can often cause confusion. So what I like to do is describe it like this. If I clear all this off and just redo this one, I'm going to do A in green. So that's A, and then I'm going to do not B in red. So not B is everything outside of B. Okay. The intersection means both colors. So like we saw in the previous one, it's just this crescent moon shape. The union means any color. So therefore that's why it's everything but the kind of crescent moon for B. So the intersection means both, the union means any color. Finally, looking at these, again, like BIDMAS, our brackets work first. So we do A intersection B, which is just this middle part, and then the complement means not that. So it's everything but that center bit. So it's just everything outside of the intersection. And similarly with the next one, the union is both circles, so the complement, which is on the outside of both of them, it's just everything around the outside. And we get that. And that's what we would do for our shading. So I hope you found this video useful on all those topics. Here's just some final tips to help you maximize your results and maximize the marks in your exams. Firstly, show all you're working out. Okay, it's about receiving partial marks, even if you can. Again, if you get the answer wrong and you've no working out, you don't get any marks. But if your working out is there, even just what you've typed into your calculator written on your sheet, you could get partial marks. And then if you do a mistype in your calculator, you'll still get the marks you need. Okay, when you get your answer, make sure you read the question again and you've answered what was actually asked of you. Okay, if they've asked you to choose between A and B and you've just written an answer of a number like £28, then it doesn't work. You have to answer the question they've actually asked you. So make sure you reread it, make sure your answer makes sense within that context. Okay, complete parts of questions in those longer 3, 4, 5 mark questions. If you see something to do with a fraction, an amount, or a ratio or percentage, try and work that bit out and at least get 1 or 2 marks. Move on. You might be able to come back and get it, but it's just about trying to pick up those marks where you can in every question. Again, drawing diagrams in pencil is really important, especially with those statistical diagrams or when you're plotting graphs. It's so easy to make a little mistake on that. Okay, and just by having a pencil, you can just rub it out, you can fix it if you make that little mistake. You can make sure your answers are accurate and you're getting all the marks you need. Attempt every question. There's no optional content in GCSE Maths paper, so just even if you guess something, it might get you a mark, it might not, but you're more likely to get a mark by guessing than by leaving it blank, because if you leave it blank, you're not getting any marks, guaranteed. And then finally, annotate your diagrams. Even if it's just your thoughts, you're writing little angles on there, anything you write in there is also marked, so you may get some marks on there. Once again, I really hope you found this video useful. And once paper 2 is done, I've got sort of an idea. I'll release another one for paper 3 to hopefully support you in prepping for that one. Okay, take care.